So request students please occupy the seats wherever it is there. So request dignitaries please come on the dais. Please sir. Very good morning to one and all present here. So today we are gathered here for the 3 days STEM fair in Karnataka Science and Technology Academy. It is a organization under the Department of Science and Technology, Government of Karnataka. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಮತ್ತೊಮ್ಮೆ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ತಾವು ವಿವಿಧ ಜಿಲ್ಲೆಗಳಿಂದ ಆಗಮಿಸಿದ್ದೀರಿ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಯಶಸ್ವಿಯಾಗಲಿಕ್ಕೆ ತಾವೆಲ್ಲ ಸಹಕಾರ ಕೊಡ್ತೀರಿ ಅಂತ ನಾನು ಭಾವಿಸುತ್ತಾ, ಸೊ ಮತ್ತೊಮ್ಮೆ ವೆಲ್ಕಮ್ ಯು ಆಲ್ ಒನ್ಸ್ ಅಗೈನ್ ಫಾರ್ ದಿಸ್ ವಂಡರ್ಫುಲ್ ಪ್ರೋಗ್ರಾಮ್ ಫಾರ್ 3 days STEM fair in KSTA. So I request all of you please stand up for the Nadagite.
ಶಂಕರ ರಮನುಜ ವಿದ್ಯಾರಣ್ಯ ಬಸವೇಶ್ವರ ಮಧ್ವರ ದಿವ್ಯಾರಣ್ಯ ಗಣ್ಣ ಷಡಕ್ಷರಿ ಪೊನ್ನ ಸಂಬಲ ಕುಮಿಪತಿ ಜನ್ನ ಕುಮಾರ ವ್ಯಾಸರ ಮಂಗಳ ಧಾಮ ಸದಿ ಕೋಗಿಲೆಗಳ ಪುಣ್ಯಾರಾಮ ನಾನಕ ರಾಮಾನಂದ ಕಬೀರರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಕೈಲಪ ಹೊಯ್ಸಳ ರಾಡಿದ ನಾಡಿ ಕಂಕಣ ಚಕಣರ ನೆಚ್ಚಿನ ವೀರೆ ಕೃಷ್ಣ ಶರಾವತಿ ತುಂಗಾ ಕಾವೇರಿಯ ವರರಂಗ ಚೈತನ್ಯ ಪರಮಹಂಸ ವಿವೇಕರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಸರ್ವ ಜನಾಂಗದ ಶಾಂತಿಯ ತೋಟ ರಸಿಕರ ಕಂಗಳ ಸೇರುವ ನೋಟ ಹಿಂದೂ ಕ್ರೈಸ್ತ ಮುಸಲ್ಮಾನ ಪಾರಸಿಕ ಜೈನರುದ್ಯಾನ ಜನಗಣ ಹೋಲುವ ದೊರೆಗಳ ಧಾಮ ಕಾಯಕ ವೈಣಿಕರ ರಾಮ ಕನ್ನಡ ನುಡಿ ಕುಣಿದಾಡುವ ದೇಹ ಕನ್ನಡ ತಾಯಿಯ ಮಂಗಳ ದೇಹ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ.
Thank you. So now we are playing KSTA Vijnana Geete composed by MD Pallavi, so and written by Dodda Rangegoda.
ಜನಜೀವನವನು ನೂತನಗೊಳಿಸಿದೆ ಅನುಪಮ ಜ್ಞಾನ ವಿಜ್ಞಾನ ವಿನೂತನ ತಂತ್ರಜ್ಞಾನ ಶೋಧನೆ ಮಾನವ ಚರಿತೆಗೆ ಜ್ಞಾನದ ಬೋಧನೆ ವಿಜ್ಞಾನದನ್ವಯ ಧಾರಣೆ ಸಕಲ ಜೀವಿಗಳ ಸಂರಕ್ಷಣೆ ಜ್ಞಾನವೇ ಶೋಧನೆ ಜ್ಞಾನವೇ ಸಾಧನೆ ಜ್ಞಾನ ವಿಜ್ಞಾನ ಸಂವರ್ಧನೆ ಜ್ಞಾನವೇ ರಂಜನೆ ಜ್ಞಾನವೇ ಪ್ರೇರಣೆ ನಿರ್ಮಲ ಬಾಳ ಉದ್ದೀಪನೆ ಅನುದಿನ ಅನುಕ್ಷಣ ಹೊಸ ಅನ್ವೇಷಣೆ ಭಾರತದ ಸಿರಿ ಸಾಧನೆ ಶಾಂತಿ ಪ್ರೀತಿ ಸಂವರ್ಧನೆ ಕೃಷಿ ಕೈಗಾರಿಕೆ ಕಂಡು ಸಂಶೋಧನೆ ನಾಡ ಮುನ್ನಡೆಯ ನಿಶಾನೆ ನಾವೆಲ್ಲ ಒಂದೆಂಬ ಭಾವನೆ ಜ್ಞಾನವೇ ಶೋಧನೆ ಜ್ಞಾನವೇ ಸಾಧನೆ ಜ್ಞಾನ ವಿಜ್ಞಾನ ಸಂವರ್ಧನೆ ಜ್ಞಾನವೇ ರಂಜನೆ ಜ್ಞಾನವೇ ಪ್ರೇರಣೆ ನಿರ್ಮಲ ಬಾಳ ಉದ್ದೀಪನೆ
Now I request Dr. Anandar, Senior Scientific Officer of KSTA, to welcome all of you for this wonderful function.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ತಮಗೆಲ್ಲ ತಿಳಿದಿರುವಂತೆ ಇಂದು ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ಮೇ 16ರಿಂದ 18ರವರೆಗೆ ಸ್ಟಿಮ್ ಫೇರ್ ಎಂಬ 3 ದಿನಗಳ ಕಾರ್ಯಕ್ರಮವನ್ನು ಪ್ರೌಢಶಾಲೆ ಮತ್ತು ಪದವಿ ಪೂರ್ವ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ನಡೆಸಲಾಗುತ್ತಿದೆ. ಈ ಕಾರ್ಯಕ್ರಮದ ಉದ್ಘಾಟನೆಯು ಈಗ ನಡೆಯುತ್ತಿದೆ. ಈ ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿರುವ ಹಾಗೂ ಅಕಾಡೆಮಿಯ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ಸುಸೂತ್ರವಾಗಿ ನಡೆಸಲು ನಮಗೆ ಎಲ್ಲ ರೀತಿಯ ಪ್ರೋತ್ಸಾಹ ಮತ್ತು ಸಲಹೆ ಸೂಚನೆಗಳನ್ನು ನೀಡಿ ಮುನ್ನಡೆಸುತ್ತಿರುವ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಧಿಕಾರಿಗಳಾದ ಡಾಕ್ಟರ್ ಎಂ ರಮೇಶ್ ಅವರಿಗೆ ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹಾಗೂ ವೈಯಕ್ತಿಕವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಇಂದಿನ ಈ ಉದ್ಘಾಟನಾ ಸಮಾರಂಭದಲ್ಲಿ ನಮ್ಮೊಂದಿಗೆ ಭಾರತದ ಮೊದಲ ಬಾಹ್ಯಾಕಾಶ ಪರಿಸ್ಥಿತಿ ವೀಕ್ಷಣಾಲಯವಾದ ಸ್ಪೇಸ್ ಸಿಚುವೇಶನ್ ಅವೇರ್ನೆಸ್ ಅಬ್ಸರ್ವೇಟರಿಯ ಡೆಪ್ಯೂಟಿ ಪ್ರೋಗ್ರಾಮ್ ಮ್ಯಾನೇಜರ್ ಆಗಿರುವ ಡಾಕ್ಟರ್ ಬಿಕ್ರಮ್ ಪ್ರಧಾನ್ ರವರಿದ್ದಾರೆ. ಡಾಕ್ಟರ್ Pradhan has done MS in Astrophysics at Indian Institute of Space Science and Technology, Thiruvananthapuram, Kerala. He earned his PhD in Space Science from University of Liège, Belgium. He has worked on several projects, among them important are space debris detection and characterization through International Liquid Mirror Telescope, Nainital, India, NanoSat project, Milli-optical interferometer, gravitational lensing, and he worked as a senior project associate at Aryabhatta Research Institute of Observational Sciences. He also worked as research associate and led the installation of India's first liquid mirror telescope. He has worked as a scientist and engineer at ISRO. At present, Dr. Pradhan is working as Deputy Program Manager at Space Situational Awareness Observatory in Bengaluru. Dr. Vikram ಪ್ರಧಾನ್ ರವರಿಗೆ ಅಕಾಡೆಮಿ ಪರವಾಗಿ ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹಾಗೂ ವೈಯಕ್ತಿಕವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಈ ಸಮಾರಂಭದಲ್ಲಿ ನಮ್ಮೊಂದಿಗೆ ಇಸ್ರೋ ಸಂಸ್ಥೆಯ ವಿಜ್ಞಾನಿಯಾದ ಶ್ರೀ ಎಚ್ ಎಲ್ ಶ್ರೀನಿವಾಸ್ ರವರಿದ್ದಾರೆ, ಅವರಿಗೆ ಅಕಾಡೆಮಿ ಪರವಾಗಿ ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಈ ಸಮಾರಂಭದಲ್ಲಿ ಭಾಗವಹಿಸಿರುವ ಶ್ರೀ BS ಕೃಷ್ಣಮೂರ್ತಿ, ಡಾಕ್ಟರ್ ಅಭಿಷೇಕ್ ಆ್ಯಂಡ್ ಇಸ್ ಟೀಮ್ ಫ್ರಮ್ ಗ್ರಾವಿಟೇಷನಲ್ ಸೈನ್ಸ್ ಫೌಂಡೇಶನ್ ಮೈಸೂರು, ಇವರಿಗೂ ಸಹ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿರುವ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಗೂ ಶಿಕ್ಷಕರಿಗೆ, ಉಪನ್ಯಾಸಕರಿಗೆ ಹಾಗೂ ವಿದ್ಯಾರ್ಥಿಗಳ ತಂದೆ ತಾಯಿಯಂದಿರಿಗೆ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜಿಸಲು ಶ್ರಮಿಸಿರುವ ನನ್ನ ಎಲ್ಲ ಸಹೋದ್ಯೋಗಿಗಳಿಗೆ ಹಾಗೂ ಇಲ್ಲಿ ನೆರೆದಿರುವ ಎಲ್ಲ ಗಣ್ಯರಿಗೂ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತೇನೆ. ಧನ್ಯವಾದಗಳು.
Thank you, sir. Indeed, welcome you also for this program. Now I request all the dignitaries on the dais formally inaugurate this function by watering the plant. Thank you, sir. Now I request Sri H.L. Srinivas sir, scientist from UR Rao Satellite Application Center, ISRO, to say a few words on this gathering.
ಗುಡ್ ಮಾರ್ನಿಂಗ್. ವೇದಿಕೆಯ ಮೇಲಿರುವ ಗಣ್ಯರೇ ಹಾಗೂ ಪ್ರಾಧ್ಯಾಪಕ ವೃಂದದವರೇ ಹಾಗೂ ನನ್ನ ನೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಈ ದಿನ ಸಂತೋಷದ ದಿನ. ಕಾರಣ, ಈ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಭವನದವರು ಒಂದು ಸ್ಪೆಷಲ್ ಪ್ರೋಗ್ರಾಮ್ನ ಏರ್ಪಡಿಸಿದ್ದಾರೆ. ಈ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ ನಮ್ಮ ಇಸ್ರೋ ಕಡೆಯಿಂದ ಒಂದು ಸ್ಪೆಷಲ್ ಬಸ್, AC ಓಲೋ ಬಸ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಎಕ್ಸಿಬಿಷನ್ ಬಸ್ ಆ ಥರ ಮಾಡಿ ಇಲ್ಲಿಗೆ ತಂದಿದ್ದೀವಿ. ಅದರ ಉದ್ದೇಶ ಏನಂದರೆ, ನಾವು 1963ಇಂದ ಇದುವರೆಗೂ ಏನೇನು ಸಾಧನೆ ಮಾಡಿದ್ವಿ ಇಸ್ರೋ, ಆ ಸಾಧನೆಯೆಲ್ಲ ಆ ಬಸ್ಸಲ್ಲಿ ಎಕ್ಸಿಬಿಟ್ಸ್ ಆಗಿ ಹೊರಹೊಮ್ಮಿದೆ. ಓಕೆ, ಇದರ ಇನ್ನೊಂದು ಮುಖ್ಯ ಉದ್ದೇಶ ಏನಂದರೆ, ನಮ್ಮ ಕರ್ನಾಟಕ, ನಮ್ಮ ಇಂಡಿಯಾದಲ್ಲಿರೋರೆಲ್ಲರೂ ಇಸ್ರೋಗೆ ಬರಲಿಕ್ಕಾಗಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರ ನಾವೇನೇನು ಅಚೀವ್ ಮಾಡಿದ್ವಿ ಅದನ್ನು ನಮ್ಮ AC ಓಲೋ ಬಸ್ಸಲ್ಲಿ ಎಕ್ಸಿಬಿಟ್ ಮಾಡಿ ಎಲ್ಲ ಕಡೆಯೂ ತಗೊಂಡು ಹೋಗ್ತಾಯಿದ್ವಿ. ಇದನ್ನು ಹಳ್ಳಿಗೂ ತಗೊಂಡೋಗಿ ಸ್ಪೆಷಲಿ ಗೌರ್ಮೆಂಟ್ ಸ್ಕೂಲ್ಗಳಿಗೆಲ್ಲ ರೀಚ್ ಆಗಬೇಕು. ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೂ ಏನೇನು ಸಾಧನೆ ಮಾಡಿದ್ದೀವಿ ಅಂತ ತೋರಿಸ್ಲಿಕ್ಕೆ ಈ ಬಸ್ ಇದೆ. ಇದರಲ್ಲಿ 1975ಇಂದ ಆರ್ಯಭಟದಿಂದ ಹಿಡಿದು ಇವಾಗ ಮಂಗಳಯಾನ್, ಚಂದ್ರಯಾನ್ ಉಪಗ್ರಹ ಎಲ್ಲ ಉಡಾವಣೆ ಮಾಡಿ ಅದೆಲ್ಲ ಇದ್ರ ಒಳಗಡೆ ಇದೆ. ರಾಕೆಟ್ಗಳಿದೆ. ನಮ್ಮ ಅಬ್ದುಲ್ ಕಲಾಂ ಮಾಡಿದ ಮೊದಲನೇ ರಾಕೆಟಿಂದ ಹಿಡಿದು ಇವಾಗ GSLV Mark 3 ರಾಕೆಟ್ವರೆಗೂ ಇದೆ. ಆಮೇಲೆ ಮುಂದೆ ಇನ್ನು ಒಂದು 2 ವರ್ಷದೊಳಗಡೆ ನಾವು 3 ಇಂಪಾರ್ಟೆಂಟ್ ಸಾಧನೆ ಮಾಡ್ತೀವಿ ಇಸ್ರೋದವರು. ಅದು ಒಂದು ಬಂದ್ಬಿಟ್ಟು ಗಗನಯಾನ್ ಪ್ರಾಜೆಕ್ಟ್ ಅಂದ್ಬಿಟ್ಟು. ಓಕೆ, 3 ಜನ ಸೈಂಟಿಸ್ಟ್ಗಳು 400 ಕಿಲೋಮೀಟರ್ ಮೇಲ್ಗಡೆ ಹೋಗ್ಬಿಟ್ಟು 3 ದಿನ ಇದ್ಬಿಟ್ಟು ವಾಪಸ್ ಬರ್ತಾರೆ. ಅದು ಒಂದು ಮಾಡಲ್ ಇಟ್ಟಿದ್ದೀವಿ. ಯಾವ ಥರ ಬರ್ತಾರೆ, ರೀಯೂಸಬಲ್ ರಾಕೆಟ್ ಅಂತ ಇದೆ. ಅದನ್ನು ಲಾಸ್ಟ್ ಒಂದು 2 ವೀಕ್ ಬ್ಯಾಕ್ ನೀವೆಲ್ಲ TVಲೆಲ್ಲ ನೋಡಿರಬೇಕು, ಸಕ್ಸಸ್ಫುಲ್ಲಾಗಿ ಲಾಂಚ್ ಆಗಿದೆ ಅದು ರೀಯೂಸಬಲ್ ರಾಕೆಟು. ಅದನ್ನು ಇಲ್ಲಿದೆ. ಪ್ರತಿಯೊಂದು ನಾವು ಆರ್ಯಭಟದಿಂದ ಹಿಡಿದು ಮಂಗಳಯಾನ್ವರೆಗೂ, ಗಗನಯಾನ್ವರೆಗೂ ಏನೇನಿದೆ ಅದೆಲ್ಲ ಒಳಗಡೆ ಇದೆ. ಅದನ್ನೆಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಮುಟ್ಸೋದೇ ನಮ್ಮ ಧ್ಯೇಯ ಇರೋದು. ನಾವು ಎಲ್ಲ ಕಡೆಯೂ ಎಲ್ಲ ಡಿಸ್ಟಿಕ್ಗೂ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ಇವಾಗ ಎಲ್ಲ ತಾಲೂಕುಗಳಿಗೂ ಹೋಗ್ತೀವಿ. ಯಾರಾದರೂ ರಿಕ್ವೆಸ್ಟ್ ಕೊಟ್ಟರೆ ನಾವು ಆ ಬಸ್ಸು ಆಟೋಮೆಟಿಕ್ಕಾಗಿ 1 ಮಂತ್ ಬಿಫೋರು ನೀವು ನಮಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ ಕೊಟ್ಟರೆ, ಈ ಥರ ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಮಾಡ್ತಾಯಿದ್ದೀವಿ, ಒಂದು 3,000 to 4,000 ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಬರ್ತಾರೆ, ಎಲ್ಲರನ್ನೂ ಕರೆಸ್ತೀವಿ, BOಗೆ ಹೇಳ್ಬಿಟ್ಟು ಎಲ್ಲರನ್ನೂ ಕರೆಸ್ಬೋದು. ನೀವು ಎಲ್ಲ ಸ್ಕೂಲವ್ರನ್ನೂ ಮಕ್ಕಳನ್ನೆಲ್ಲ ಕರೆಸಿದ್ರೆ ನಾವು ಅಲ್ಲಿಗೆ ಬರ್ತೀವಿ. ಅಲ್ಲಿ ಬಂದುಬಿಟ್ಟು ಒಂದು ದಿನ ಪ್ರೋಗ್ರಾಮ್ ಮಾಡ್ಕೊಂಡು ವಾಪಸ್ ಬರ್ತೀವಿ. ಅದೇ ಇದ್ರ ಉದ್ದೇಶ. ಅದರಿಂದ ಈ ಬಸ್ ಒಳಗಡೆ ಏನೇನಿದೆ ಅದೆಲ್ಲ ನೋಡಿ, ಈವನ್ ಬಸ್ ಆಚೆ ಕಡೆನೂ ಇದೆ ಕೆಲವೆಲ್ಲ, ಅವೆಲ್ಲ ನೋಡಿ ತುಂಬ ಜ್ಞಾನದ ಏನಾದರೂ ಕ್ವಶನ್ಸ್ ಇದ್ದರೆ ಕೇಳ್ಬೋದು ನೀವು. ಓಕೆ, ನಾವು ಅಲ್ಲೇ ಇರ್ತೀವಿ. ಕ್ವಶನ್ ಇದ್ರೆ ಕೇಳಿಬಿಟ್ಟು ನೀವು ವಿಜ್ಞಾನದ ಬಗ್ಗೆ ಅವೇರ್ನೆಸ್ ಎಲ್ಲ ನೋಡ್ಕೊಳ್ಬೇಕು. ಏನೇನು ನಮ್ಮ ಇವಾಗ ಬೇರೆ ದೇಶದವರೆಲ್ಲ ಸುಮ್ಮನೆ ಒಂದು ಪಿನ್ ಅಂದರೆ ಅದನ್ನು ಆನೆ ಥರ ತೋರಿಸ್ತಾರೆ. ಆದರೆ ನಮ್ಮದು ಆ ಥರ ಇಲ್ಲ. ಇವಾಗ ನಮ್ಮದು ಏನು ಮಾಡಿದೆ ಅದನ್ನು ತೋರಿಸ್ಲಿಕ್ಕೋಸ್ಕರನೇ ಬಂದಿದ್ದೀವಿ ನಾವು. ಓಕೆ, ಅದರಿಂದ ದಯವಿಟ್ಟು ಇದನ್ನು ಉಪಯೋಗಪಡಿಸ್ಕೊಳ್ಳಿ. ಓಕೆ, ಧನ್ಯವಾದಗಳು.
Thank you, Srinivas sir, for inciting us on the importance of space science and space on wheel. Now I request today's chief guest, Dr. Bikram Pradhan, scientist from ISTRAC, ISRO, to address the gathering on this occasion. Over to you, sir.
Good morning, everyone. I can see many bright faces. Future of Karnataka, future of India, and their guides. I saw the brochure of this fair. I saw that students are participating from on the topics of physics, chemistry, maths, and biology, right? How many of you are participating in physics? Can I see? Raise your hand. Okay, quite numbers. And mathematics? Okay, so okay. I see. Okay, I got to know that you are yet to study physics, chemistry, maths, and biology, but already you might have studied a science as a whole, right? What I did during my PhD is called a liquid mirror telescope. Okay, it is world's first liquid mirror telescope that got installed in India. Usually telescopes, you guys have seen any telescopes before? It has a mirror, right? So it is metallic, it is hard surface, mostly made up of aluminum. Something reflects very nicely. But liquid mirror telescope, we use mercury. Mercury in its room temperature, it is in liquid form. And it has very low coefficient of thermal expansion. What does that mean? That if you change the temperature, it doesn't expand or contract much. Okay, so we use it. Do you guys know if you change the temperature, something can expand and contract, right? So mercury doesn't do that. So what we do is we make a bowl. Okay, that old type this music player will be there. Gramophone, where there will be a round table. It rotates. We will create a ball, and we will rotate it. While it is rotating in a constant velocity, we will pour the mercury. Then what happens? You guys will be drinking tea or coffee. Not yet, not you, but your parents or someone. You might have seen, isn't it? So, Horlicks you might be drinking. So there, in the milk you put Horlicks and you stir it, right? While stirring it, you see that a parabolic surface will get formed. The faster you stir, the focal length of the parabolic surface will decrease. It will go deeper. The slowly you stir, the shallower it will become. So this is the same concept we do in the liquid mirror. There is a rotating bowl. You pour mercury slowly. You rotate it. Then it will spread. And according to laws of physics and mathematics, it will take a shape of parabola, perfect parabola, which is essential for a telescope to focus light. Today I will be talking about these telescopes, how a simple thing can give rise to telescopes that helps us discover wonders of outer space, that made us fascinated about space. All of us got inspired. Most of us in ISRO, my colleague, can confirm that we are fascinated about space while sleeping on during the night, watching the sky. It fascinates everyone. Don't you guys think about it? Well, Bangalore, it's a different place at all, You don't see sky much, but if you go to your village or native place where light pollution is less, you can see a lot of stars, and those looks beautiful. How a pinhole camera can give rise to a telescope? You guys have done pinhole camera experiment? All of you? Yes? So what have you done? Like make a pinhole in a cardboard and saw the projection of a candle, right? Can we go to the next slide? This is what you have done, right? So here you see, okay, I have to be in front of the mic. Can you hear me now? All of you? So, sir, this part of the light, can you see? Yes. Is it better now? Last row?
Sir.
Okay. Hello? Am I audible? How is it now? Nothing. This is the optimal place, I guess. It's good now? Ah, thank you. Excellent. So what is the work of this pinhole? It focuses light on a single point. Focus light. All telescope does focusing light. It takes light, focus it on a camera. That camera takes the image and you see it. Pinhole camera focuses the light. You see, when you have done the experiment, you would have seen this candle in an inverted space, isn't it? So you can image anything from a pinhole camera. During solar eclipse, what they used to do is, you see here, this lady, she is holding a pinhole camera and pointed towards sun. So you can see the image of sun on the ground like this. You cannot see sun in your naked eyes, and not everyone is having that filter that you should look through. So we can use this pinhole camera. Normal sun also you can see through this pinhole camera. You guys can do some experiment. When you go to the telescope, so here you see there is a very simple formula for this image. You know, when you go little closer, this image, this plane, if you take it little closer, the image size will decrease, isn't it? When you take it further, the image size will increase. Okay, I went further. Okay, so there is a close relation between this distance and the angle of the object. Do you agree? I am not going into too much mathematics. Simple thing I am asking. If someone is not able to understand, please raise your hand. Okay? So there is a simple relation between this height and this distance. Do you agree? Yes or no? Yes. Now, you might have seen during noon when you walk across through the trees such spots, right? So this is the image of sun through pinhole. Each spot here is one image of sun through pinhole. If you know the size of the sun, and if you can measure the width of this, you know, the size of this spot, you can find the height of the tree. Isn't it wonderful? You know, this distance you can already measure. This is a tree. Through the holes, the light is falling. So you can find the distance of the tree. Isn't it wonderful? Do any one of you know what is the width of angular size of sun? Anyone? It's half a degree. It's the same size as moon. Moon is also having half a degree size, angular size. Sun is also having half a degree size. Now you know the size. You can already find this distance. It's just a use case. All of you could get it, or it's too much? I hope all of you could get it. I want your involvement actually. Otherwise, it's, you know, if I were in your place and thank you. Hello. I will hold it. It's good now. It's good now. Okay. If I were in your place, I would not have liked someone talking, you know, just talking. It has to be a fun. Learning is fun. Should be fun. Okay. You know, this technique, early days, you know, Galileo Galilei, everyone knows. So he used this technique. Galileo Galilei used this technique, you know, to find the size of a star using this pinhole camera. You know, what he did is he used a wire with the width of a star, this much thick wire he used, okay, and he placed in front of him in such a distance that the star got completely covered by the wire. Now he knows the angular size of the you know, star, because he knows the size of the wire. He used this technique in 1632. Guys can see? Huh? Such a simple technique. Now every part of a telescope can be a pinhole camera. Your eyes are a pinhole camera. Everyone can put your thumb like this you put, and you see something. You see yourself. You see yourself, or this mobile. Now close one of your eyes and block this phone with your thumb. Okay? Now you open that eye and close the other eye. Your thumb got shifted? Everyone? You see, this is one pinhole, this is one pinhole, this is one telescope, this is one telescope. Okay? We will study more about it. Both the telescope, they are capturing images, processing here. It is wonderful. It's God's creation. We will study more about it. We have used such technique for better vision. I will explain to you later. You see, each part of the telescope, each part, here, infinite pinhole that focuses light in a detector. This light is coming from where? From the stars. Okay? And it is focusing here. Stars, they don't have shape. You know, it is very far. You cannot resolve it. See. Can you see this cap? If I place it like 1 kilometer away, can you find the shape of this cap? No one can find the shape, right? You will see a pinpoint. All the stars are pinpoint. There is no shape. So, Sri Galileo, when he found the size of a star, he was mistaken. It is a point source. But due to our atmosphere, it gets blurred. It's called diffraction. You guys know about diffraction? Some of you? Anyone? Ah, great. Anyone else? It's very interesting, very good. Diffraction is when a light comes through a aperture, some opening, you know, it lights bends. It bends, which is called diffraction. And bending happens through the edge, not at the center. Okay? So one pinpoint object can look like a point spread object. So one star though it is just a point, it should be like this red dot, but it looks like this. You understood? Now we will do this experiment. Okay? Now the size of this object depends on how big your telescope is. The bigger the size, the smaller is the object. This size will decrease. theorem you can see the shape of this camera. See the shape of the camera, third row. You cannot see the shape. It is square. Do you see the shape? No. So this experiment will work better from the third row because you cannot see. It will be a point source from third row. Second. Experience, they can go back and see and come. But as of now, please be seated. What you have to do is, everyone can see this light. How do I place it? Sorry. We will put it in place, like here or somewhere. Be here. Everyone can. Oh yeah. Everyone can see now. Can we switch off all the lights? Everyone can see this. Now carefully punch one hole carefully, as circular as possible, as small as possible. It has to be a pinhole, and see through it. You could see? Everyone could see? This is called airy disc. You can easily mathematically define it. When you go to your bachelor, you will see you read a very beautiful theorem called convolution, Fourier transform. It is a great theorem. You will read it and you will understand why this airy disc appears. Now I want all of you make a similar hole very close to it. A similar hole very close to the first hole, very close, very close. Yeah, now you can make the hole, but it has to be very, maybe 1 millimeter apart, maybe less than 1 millimeter apart. Could you make? Cannot see? Anyone else? Maybe. Maybe we will switch off the light and we'll see. Anyone? Not successful? Okay. Anyone else? You could get? Wonderful. Anyone else? Oh, wonderful. Now, please tell me what is the, this is too big. This is too big. See, the interference pattern here will be exactly perpendicular to the two holes. Am I right? You can 90-degree turn and see that this interference pattern will also turn. Could you guys agree? You can do the same experiment. Whoever are not able to succeed, they can do it at home also. such a simple thing. All of you use smartphone or parents are not giving? Okay, you take your parents, you borrow for 2 minutes and you can do this experiment. Okay? Shall we wind up this experiment? I have some few lines to say apart from all this. All of you satisfied? Very good. Sir, we can switch on the lights. Oh, I forgot to display this. No problem. Next slide. Next slide. Yeah, that's it. Yeah, that's the last one. What I meant is, science is very simple. The teacher has to be excellent. You have so much of responsibilities, sir, madam, everyone. It is so simple, everyone can understand. No one is dumb in this world. Someone takes a few seconds to understand something, someone can take few hours to understand something. It's about attitude, if you keep it up. I myself, during my childhood, in my school time, there were 37 pupils in my class. I used to stood 35. Then I started, my parents sent me to boarding school after my 10th. So there I was studying with my friends and they were studying day and night. I saw that, okay, such study also happens. A sleepless night study also can happen. Then I also did, and I stood second in my class. Then during engineering, I carried on and I stood first in my class. So I strongly believe that no one is dumb, no one is a poor student. It's about attitude. You should know what you are doing. Okay? Don't just study to just study. You have to understand it, and if you don't understand it, keep trying it. You have so much time. We don't have time. You are so privileged. Please study. Please make Karnataka great. Please make India great. And do great things for our humanity. Don't use your brain for something else. You have very good brains. That's it. Please keep the attitude up the level. Okay? Everything will be fine. I wish all the best to this fair and everyone who is present. Thanks for letting me speak to all these bright students who could successfully do the experiments. Also the last row, I highly appreciate. And thanks to ISRO colleague, my colleague, and the organizer there. Thanks a lot. Thanks to you also. Thanks.
Beautiful words. You motivated all of us. No, we have to always dream high to achieve success and make Karnataka great and also India great. Thank you so much for your kind words, sir. Now I request our source of inspiration, Dr. A.M. Ramesh sir, CEO of KSTA, to give the presidential remarks on this occasion.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಎವ್ರಿಬಡಿ. ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ. ಮೊದಲನೇದಾಗಿ ಈ ಸ್ಟೆಮ್ ಫೇರ್ಗೆ ಬಂದಿರುವ ಎಲ್ಲರಿಗೂ ಅಕಾಡೆಮಿ ಪರವಾಗಿ ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. ವೇದಿಕೆ ಮೇಲೆ ಆಸೀನರಾಗಿರುವ ಡಾಕ್ಟರ್ ಬಿಕ್ರಮ್, ಡಾಕ್ಟರ್ ಶ್ರೀನಿವಾಸ್, ಮೈ ಕಲೀಗ್ ಡಾಕ್ಟರ್ ಆನಂದ್, ಶ್ರೀನಿವಾಸ್, ಉಮೇಶ್, ಕೃಷ್ಣಮೂರ್ತಿ ಸರ್, ಡಾಕ್ಟರ್ ಸಾಹು ಮೇಡಮ್, ಡಾಕ್ಟರ್ ಶ್ಯಾಮ್ ಸುಂದರ್, ಡಾಕ್ಟರ್ ಅಭಿಷೇಕ್, Dr. Balkrishna, and all the teachers and students. In fact, STEM, when we wanted to organize a STEM fair, there was a little bit of resistance that holidays are there, students won't come. In spite of that, we took a chance to organize. There has been a good response. In fact, yesterday also somebody had mailed me saying that now there is holidays, how can the students be contacted and sent information about STEM fair? I told them now everybody has got mobile phone, everybody can access email, access WhatsApp. If we send a information, in no time they get. So that was the plan that we did to communicate with the students and parents for this STEM fair. In fact, we are very grateful to ISRO, Dr. Bikram. You are a very inspiring speaker. Your talk was really inspiring for two students as well as for us. Srinivas sir has been very helpful and cooperative. Last time also I had brought the space on wheel for us. This time again, when I requested him, immediately he agreed and brought. The space on wheel will be there for 3 days in KSTA. You can tell your fellow students and friends to come and watch space on wheel. And we'll be getting mobile planetarium also. We have requested. It will be there by another 1 or 1.5 hours. It's coming from Tumkur. You can experience planetarium also. In fact, we wanted to organize it in a much bigger way, but because of holidays, we wanted to confine it to this hall. Next time we would like to organize in September. We'll give much publicity. We'll be organizing in a big way, and teachers who are present here are requested to send their students. For 3 days, we will be having exciting moments. We have Abhishek and Dr. Shyam Sundar sir. They will be delivering talks and also models they will be exhibiting. And first session is by Dr. Sahu madam. She will be making hands-on in physics. And on the last day, dance with mathematics by our renowned mathematician Krishnamurthy sir. Will make you all to dance with mathematics in the last session, so don't miss it. In fact, KSTA was started in the year 2005 under the chairmanship of great space scientist. You know him? Professor U.R. Rao. He was the father of satellite technology in India. On 19th April 1975, first satellite Aryabhatta was launched, and he was the leader. And the average age of scientists and engineers who were involved was 25 years. All were very young, like our Dr. Bikram. They made it possible that India got into space. That's why Professor U.R. Rao always used to say, dream big. He was our chairman for nearly 12 years. After that, another great space scientist, Padma Shri Dr. S.K. Shivkumar, was our chairman for 1.5 years. All of you have heard of Deep Space Antenna Network in Ballard, big antenna, Ballard students. Then you should catch hold of Dr. Bikram and get to visit Ballard. It is India's largest antenna is there in Ballard, Istrak. You can go and visit there. He was the director at that time when they made this one deep space antenna. With deep space antenna, they could connect with the Chandrayaan, Mangalayaan, and other satellites. So, with one more example, I would like to close my words. Dr. APJ Abdul Kalam, all of you have heard? And have you read Ignited Minds? Ignited Minds? No, then you should go and buy that book and read. It's a very, very interesting book. And in that book, for a couple of times, one name always comes, that's of Shiva Subramaniam. He was his teacher during his high school. Because of him, he took up aerospace as his career. He used to take them out and make the students watch how birds used to fly. Because of that, APJ got inspired and started to work on aerospace since his high school days. Then he joined aeronauticals, and rest is history. What I would like to say is, just mere theory doesn't lead you anywhere. As Dr. Bikram showed, it is only the hands-on, minds-on concept which you can remember for a long time. And that's why for these 3 days, we'll be having hands-on, minds-on only, very less of theory. All of you, I request all of you to be here at 10 o'clock for another 2 days. Till 5 o'clock, we will be having these sessions, and we have arranged for lunch also, and also snacks in the evening. I hope all of you will enjoy. I'm sure 3 days will help you to broaden the horizon of your knowledge in basic science and applied science. I wish you a great future. Thank you very much.
Thank you very much, sir, for your kind words. Now I request my colleague, Mr. Umesh Gatgi, Scientific Officer of KSTA, to propose vote of thanks on this occasion.
ಎಲ್ಲರಿಗೂ ಶುಭೋದಯ. Very good morning to one and all. It is my great pleasure to be part of this STEM fair and express gratitude to all who are the reason behind today's successful inauguration of this STEM fair. First and foremost, I would like to thank today's chief guest, Dr. Vikram Pradhan sir, scientist ISRO, for accepting our invitation and being with us here today and sharing their experience with experimental presentation on this inaugural function. On behalf of KSTA, on behalf of all of us here present, and on my own behalf, thank you very much, sir. Also, I would like to thank Shri H.L. Srinivas sir, scientist URSC ISRO, for helping us in organizing Space on Wheels for 3 days in this STEM fair. Thank you very much, sir. Also, I would like to thank our CEO, Dr. A.M. Ramesh sir, for planning and making this STEM fair happen in very short span and guiding us to organize this event and make this grand success. Thank you very much, sir. We'd like to thank all the speakers, resource experts, scientists, Mr. Sarmishta Sahu, former Associate Professor of Physics, Dr. P. Nagaraj, Dr. Shri B.S. Krishnamurthy sir, Dr. Keshav Bulbule sir, Dr. Balkrishna Adiga sir, Dr. N.M. Shamsundar sir, Dr. S.N. Prasad sir, and Dr. Abhishek and his team for accepting our invitation and being part of this STEM fair for 3 days program. Thank you very much on behalf of all of us present here and on behalf of KSTA. Also, I would like to thank KSTA entire staff, technical, non-technical, administrative team for their support. And last but not least, I would like to thank all the participants, students, professors, teachers, and more importantly, parents for encouraging their children for by participating in the STEM fair and for your valuable presence, without whom this program would have not been possible. Thank you very much. Thank you one and all.
Thank you very much, Mr. Umesh Gatgi. And now we are going to inaugurate the Space on Wheel outside. So after that, we can have a small 10 minutes tea break, and then we can come back and we can have a session on Mr. Samisra Shawu Madam talk. So please assemble there for the Space on Wheel inauguration.
Studying because you want a 100% certificate, get a job, yes or no? No. You want to understand what is happening around you. Everywhere you look around, you will find science, mathematics, technology, engineering in every field that you are working on. Okay, so that is what you need to do right away as you are growing up. So what do I plan to do today? I am a physics professor, but it doesn't matter whether I teach physics or chemistry. We want to see things around us and want to understand. Okay, I will switch it off. Just 1 minute. made it mute so it won't disturb us anymore. Okay. So the purpose to come over here was to show you something that we are seeing all the time. Sometimes we feel we build our knowledge. Sometimes we build our knowledge based on whatever we see, whatever we observe, and then we try to analyze and find out the solution. Okay? So that is what we plan to do today's session. I will show you some small demos and I will ask you questions. And I want you to interact. It should not be just one-sided. I should not be talking and you be listening. That is not interesting. Vikram sir told us it should be an interactive process. And how will it be interactive? Provided you are interested. So you must try to answer, not that you don't know the answer. You know the answer, but you must tell it aloud. And when you tell it aloud, you are making the others aware of it. Okay? At the end of the thing, when you have told something, you will feel very good about it and you will be sharing your knowledge with your friends around you. That is why you need to answer. So no inhibitions, you will try to answer. Okay? So what do I start with? All of us have seen when we are having on a doorstep or thing place like this, we put up thing 4 feet over here and we are wearing a slippery shoe. What happens? What happens? You slip. Okay, why do you slip? What is the reason you slip? Friction is reduced, and only if friction is reduced, if I stand over here with my wheel thing, what, skating wheel, will I slip? No. If I am keeping it like this, it is an inclination. Okay, it's an inclination. So the moment you keep something over here, it will roll down. Yes, it is rolling down. Why is it rolling down? Gravity is pulling it down. So gravity is a force which is pulling it down, right? That is the reason it is going from a higher height to a lower height. Okay? When it is at higher height, what is the energy of this? How do you measure the energy or know the energy? Pardon? It is the potential energy. So if I say it is from a height h, then it is having potential energy mgh. Okay? Since if at this point the h is very small, m is the same, g is the same, potential energy over here is high, potential energy over here is low, and therefore it is rolling down. Right? So if that is so, then I am doing something else. I am taking one thing, whatever you want to call it. I like to call it a monkey. This is my monkey. Just watch what the monkey is doing. He is my pet monkey. So when I tell him something, he sorts of listens to me and he does whatever I want him to do. So dear monkey, please come down somersaulting. Come to my left. Come to my right. Come to my left, come to my right, come faster, do it slowly. I don't want you to somersault very fast. Faster, slowly. What am I doing? Why is it listening to me? Does it have a brain? Does my monkey have a brain like you, me and everybody? No. Then why is it doing like this? When I wanted him to come to my left, what was I doing? I was inclining it so that the potential energy of this increases and therefore it was coming to my left. When I wanted it to move faster, what did I do? The inclination became more. So when the potential energy is more and it is decreasing, it gets converted into what? Kinetic energy, and therefore it was moving faster. Kinetic energy greater means its velocity has to be greater. But was it having only velocity? How did it manage to somersault? Friction? Yes. Please see how it is somersaulting. What is the reason? How it is somersaulting? What is a somersault? It is going head over heels, head over heels, head over heels, right? How is it somersaulting? Friction and weight. Very good. Friction and weight. And look at the design. Not only the friction, not only weight, it is the design. Please note what I have done. This is just a your small ping pong ball. I have taken it into two halves. Sir was telling make it hands-on. I would have loved to make it hands-on. In fact, I did it in my college many a times. But here, since the time is limited, I have no time for you to do it yourself. So, I am just telling you how it has to be done. Okay? So, take any plastic ball, cut it into two halves. Then it becomes two cups. Okay? Take your agarbatti cylinder, some hard cylinder, cut a small piece. Okay? You can take PVC pipe and put it over here, no problem. And then I have taken one really heavy ball, spherical ball, heavy ball. Okay? I have put it inside it. You can hear it. When I keep it like this, where is the ball? It is over here. Okay? When it is moving, please see what is happening. It is going this side. It is going like this because it is horizontal. But it is not fully horizontal, then it will sleep like this. But if it is not fully horizontal, then it is capable of getting up. Because it is able to get up, it is somersaulting. Can you see that? The ball is not exactly horizontal. When it is, this side is lower, it is going to lift this up. Okay? So, when it is lifting this up, the ball goes at the center. It is at equilibrium position and therefore, it should rest over here. But there is inertia. It was moving like this and therefore, because of its inertia of motion, it is again toppling down like this and therefore, it is capable of repeating. Okay? So, what are the forces that are coming into play? Somebody told very nicely, gravitational force and the friction force. But how it is rotating, when it is rotating, what is happening? What is happening? When it is rotating, what is happening? There is a torque. So, the torque, I don't know, probably you have never heard of a torque. So, it is something, a force in the circular direction which is capable of rotating it. So, all put together, it is making my monkey do the way I want it to do. Okay? Can you try it out at home? Did you understand how it has to be done? When you are doing, you will face a lot of challenges. You try doing this little longer, little shorter and see what is happening. That is your home task. I am not going to make you do it now, but you can do it and try it out. You can get a ball somewhere, a heavy ball. I have taken a steel ball. You can take anything that is available with you. It is not magnet. Any ordinary steel ball will do. Okay? So, did you realize what is happening and how it is happening? Yes? Okay. Now, I will show you something which I was talking to you about a slope. I can show it to you like this. So, what am I doing? I am creating an incline. It is a ramp. Okay? As I told you, if I keep anything like this, naturally, because its potential energy is decreasing, it will start moving downwards. All right? So, I am showing you how it is moving downwards. I want to keep this over here. So, what do you think should happen? It should move down. That is your belief, right? Not budging from its place. It is standing wherever it is. Okay? But then I want to keep it over here and see what's happening. The slope became too much, therefore it was behaving like that. When I am keeping this over here, it refuses to move. It is moving down, correct? It is moving down. But when I keep this over here, this is also a circular thing. This is also a circular thing. Nothing different. Here also there is a circular part. But when I keep it over here, it doesn't budge. When I am keeping it over here, it's moving up. What do you think is the reason? Have you seen anything moving up by itself without any energy pumped into it? It doesn't. Can you move up a hill all by yourself without any energy being pumped in? Not possible. Okay, but this is doing it. Is it a magic? Is it a magic? Definitely not. So could anybody explain what is happening? Please remember, potential energy, that's all you need. Yes? Come on. Okay, you are probably correct, but not distributed. We'll just see over here. When I'm keeping it over here, where is the center of mass of this body? Where is the center of mass? Do you know what a center of mass is? Yes? So where do you think? This is a symmetrical body. So where do you think the center of mass should be? Somewhere at the center. Center of mass has to be somewhere at the center for symmetrical bodies. Okay? So if I look at the line which is passing from this and coming out from this, somewhere at the center it will be there. That is the center of mass. And all your measurements are made from center of mass. Okay? So whenever you make a measurement of a body which is extended, you will make your measurements from the center of mass. So when I keep it over here, if the center of mass is somewhere over here, what is the height? I am just putting my finger, not measuring, making an estimate. Can you see from the table what is the height? Okay? Now when it is coming over here, the center of mass is over here. Look at the position. Can you see that? So what is happening? When I am keeping it over here, the potential energy is more. When I am keeping it over here, potential energy is less. Every body has the tendency to move from higher energy state to lower energy state. So that is exactly what it is doing. It is moving from higher potential energy to lower potential energy. That is why it was moving uphill. It looks as if it is fascinating, but it is believing or behaving according to the principles of nature. It is not disobeying nature. It always wants to move from higher potential energy to lower potential. When I keep it over here, the potential energy is more. When I keep it over here, the potential energy is less. So it was moving from higher potential energy to lower potential energy. But this, because of its design, look at this cone. What I have done, how I have done, I will tell you that. Because of its shape, its potential energy over here was more, over here it was less. And therefore it is moving from higher potential energy to lower potential energy, but it is moving uphill. Okay? Which is something very non-intuitive. You don't see anything which is automatically moving uphill. So here something is moving uphill. All right? Okay. Now I will show you something in terms of center of mass. I was just now talking to you about center of mass. Okay? So suppose I consider this to be a cylinder, almost like a cylinder. Where should the center of mass be? It's a symmetrical body. So most of the time for symmetrical body, the center of mass is at the center. So here if I talk about the axis, somewhere at the center will be the center of mass. Clear? Okay? So when I keep it like this, the body is resting vertically. Yes or no? But when I want to keep it like this, it's not able to work. It is relaxing or going to the lying down position. What is the reason, do you feel? Look at this. Because of its shape. Here I have made it exactly plane, so it is capable of sitting over here properly. But when I am keeping it like this, I have still made it a plane, but it is not sitting properly. You said of the shape. This is also a plane. In spite of it being a plane, it is not sitting over here, it is falling down. Please look over here. The center of mass over here is exactly above its area of resting. So if I consider the center of mass to be over here, it is resting over here, it is exactly at the bottom. The center of mass is exactly falling at the base of that object. But when I keep it like this, the center of mass which is over here is falling outside, and therefore it is not able to stand in equilibrium, it is falling down. The center of mass, wherever it is, gravitational force acts over there, so gravity is pulling it down, right? Therefore it is falling down. Got it? So along with potential energy, it is necessary that the center of mass should lie vertically above the base. Alright, so that is why it is standing like this, but it is not standing like this. Clear? I want you, one of you, to please come over here. Please come over here. I am giving you another mass. Okay? This is a heavy mass. I want you to use this, put it somewhere over here, so that you are able to make it stand on this surface. Did you understand my question?
Can you repeat?
I said I want you to use this and keep it wherever you feel comfortable. Don't touch the thing floor, it should be hanging, and you should keep this like this. Okay, you saw what is happening. Please look here. This is what is happening. So I am giving him another attachment, asking him to make it stand. So how will he make it stand? Think about it and suggest. Think about it. Probably he's seen it elsewhere.
No,
Never
I'm a
mind.
12th, meaning second PU student.
Second
so
PU
I already
student,
know.
so already know. So what did he do? He kept it hanging all right and it stood. So let's talk in terms of center of mass. Okay? Every body which has a mass has a center of mass. So therefore this is also having a center of mass. This is also, what's your good name?
Anirudh.
Anirudh. Anirudh has done it beautifully. So this also has a center of mass. I want you to analyze. If you simply see and forget, that will be of no use. I want you to analyze, find out the answer why it is so. Alright? So then what exactly is happening? There is a center of mass over here, which is, if it is almost a cylinder, it should be somewhere over here. This is almost a cylinder, it has over here. When he did this, do it, sir. Keep it this side, keep it a little, yeah, then only a little bit.
It should come exactly in the center.
He did it, but say, okay. Now there was a center of mass over here, there was a center of mass over here. When the two bodies combine together, it becomes one system. Now it is one system, okay. So the center of mass of the system will get adjusted. It will lie within the two center of masses. So you have one center of mass over here, one center of mass over here. So it has come to some other position over here. Okay, the resultant center of mass of the system is somewhere over here. Look at the thing, vertical direction of that position. Is it coming within the base? Yes. This is what you are doing every time. Just imagine you had a coconut tree and the coconut tree was coming down. Would you like to see the coconut tree coming down exactly onto the ground and fall down? No. So what do you do? What do you do? If you don't do anything, at least your parents will be doing. So if the coconut tree is falling like this, you put a support over here. When you are putting a support over here, what is happening? Now the center of mass of that coconut tree which was over here was falling down. Therefore, it was coming outside the base. When you are putting a support over there, the center of mass is now coming within the base. That is what is supporting it. You use it the whole time. Is that clear? Anirudh, keep it up. Keep it up. Very good.
Thank you, ma'am.
Okay. That's a great event. He did it. Fat say. Okay. Now I'll give you, I want another, maybe 2 children coming. And it is not that only second PU children will come. Everybody over here is most welcome. I want everybody to participate. Yes, please do come. Come along. Come along. Yeah. I'm giving you challenges and then we will try to analyze what is happening. I'm just creating a base. I've taken a bottle, put some sand and putting a base. I have a couple of nails over here. Okay. I'm putting one of those nails over here and I'm asking them, I'll give you 10 more nails. Please put it over this. I'm giving you 10 more nails. I want you to balance over here. You will do it. Think. See what I said? I just now said that the center of mass should be within the base. If the center of mass is within the base, it will become correct? Okay, so now think of a way, try, and then you will know. I want all the 10 nails to be balanced over here, all the 10 of them. So what could be the way? How can it be done? Okay, what's your good name? Saubhagya. I think I should write it down somewhere. Saubhagya, right? Anirudh, Saubhagya. And I want all of you to come. Correct? Yes. The center of mass should come within the base and my base is only this much. Okay? So I will take all the nails and then keep it in a pattern so that it becomes symmetrical and the center of mass becomes somewhere at the center over here. Okay? So that should be the idea. We just now saw how it can be done. Yeah? Think of it. Anybody can suggest. From there also you can suggest.
First one, keep it horizontal.
Okay. Okay. Keep it horizontal. Right. Anirudh is going to give you suggestions. Yes.
And the second one, like, first one, keep it horizontal. Like exactly on the middle.
Actually what he is saying, you will do it over here, it will be better. Yeah. Second one. Yeah, sit over there and give instructions.
So second one, like, place 2 of them equally on this side, like horizontally.
Okay.
From that, the same thing. Fill all the 10 layers, like, just place both the sides equally on the center of mass. That way we can easily make it balance.
You can easily make it balanced. Okay, so he's trying. Watch them please. Anirudh is giving them instructions and these 2 younger boys are trying it out. You also must think of it, suggest and come to a conclusion. This is how it can be done.
Keep it your hand.
It's going to be a real challenge for them. Yes? Okay. I'll give a little clue. Let's not do it over there. First we'll do it over here and then we will transfer it to that pin. Okay? Whatever you want to do it over here and see if you can transfer it over here. Possible. Possible. Yes? He has already given you some clues. He said, keep it in a format so that there is some sort of symmetry. Try lifting it. Try lifting it. They are trying something. Okay. Now, how do you grow? How do you think better and better? You have to do it probably and then see that it is happening or it is not happening. If it is not happening, what do you do next? That's how you grow. Okay? So say from the beginning, no, I don't want to try, you will never learn. He is trying it, he has made a square pattern, going to be difficult, okay? Why is it difficult? Because these are all slippery things, all of them are cylindrical and they are going to slip one over the other. Therefore, lifting it the way he was doing will be little difficult. Now, I am just giving you a suggestion. Whatever you were doing, it was an expanded thing. Try to do something like this, okay? So that you are keeping it symmetrical. Take two of them and keep it symmetrically aside. Take two of them and keep it symmetrically on the first one. Yes, yes, yes. Very good. Let them see. Yes, symmetrically I said. 10. I want all 10 to be used. You've kept 4 of this, 4 of this. If I keep fifth one over here, what will happen? It will become asymmetrical. Okay, but you've kept one like this. Can you try doing something symmetrical to that line? You have one over here. Can we keep it like this? Yes? Now you lift it up. Very good. Do it carefully. Do it carefully. Use the head for giving you the grip. Did he balance all the 10 nails on that single nail? Did it beautifully. Okay, now you will explain, where do you think the center of mass is?
The center of mass is here.
The center of mass is over here. How did you get that center of mass over there?
Because the base is here, this way.
No, because it is stabilized, you are saying the center of mass is somewhere over here. Fantastic. I said, how did you make it? What did you do?
By keeping the equal nails on one side and the other side.
So he was making a symmetrical pattern. What did he do? He made a symmetrical pattern. He kept it like this symmetrically. Then he kept 2 of them symmetrically. When you are having a symmetrical body, you can exactly pinpoint where the center of mass is. So that is how they managed it. Anirudh? No. Saubhagya and Anup. Can we give them a big hand? Saubhagya and Anup did it beautifully. Okay? So this is happening every time when the constructions are taking place. Have you realized it? When they put mesh for making the ceiling, have you seen how they make a pattern? Okay? Anything that you want to balance on one point, few points, that is how you have to take care. You have to make the center of mass well within the base. Okay? If that is true, then let's have a play over here. Can I have a girl coming over here? Where do I make you stand? Yeah. Can I have one girl over here? Thank you. Keep it up. Keep it up. Can I have one girl over here? Yes. What shall I give you? I'll give you my mobile. Okay? Where do I make you stand? It's very difficult. I don't have a stand over here. Acha, we'll put this chair out. I think I will pull it out. You stand over here with your back totally flushed, your head totally flushed on the wall. Okay? She is happily standing over there. I will give you this mobile. If you can lift it up from the ground, okay, without bending your knees. Okay? Put your leg fully. You will not bend the knees, but you will lift up the mobile. If you can take the mobile is yours. Nice. Okay. Chalo. Start. Keep it over here in front of you. I think that's better. No. Put your leg down. Totally flush to the wall. You are part of the wall.
Not even
You can bend. Yes, you can bend. But your knee should not bend. Huh? It will touch. Okay, I will move that for you, safety sake. Still move it. You are scared. What if I fall? Yes, yes. Look at her legs shivering. Okay, one more try. Here. You left the wall and came away. Why is it so difficult? Why is it so difficult? Did you realize something was happening? Why is it so difficult? Gravity is always there. There is no doubt about gravity. Gravity is not going to leave us. We are not going to leave gravity. Why was it so difficult for her to do it? She had to come out of the wall. When she was bending, the center of mass is over here for all of us. We are only cylinders only, na? Most of us are cylinders only. So the center of mass is over here. When she was bending, where is the center of mass coming? Forward. Every time she is bending, it is coming forward. So when she is trying to lift it up, it is totally outside her leg. That is why her leg was shivering like this. Until and unless she bends down her knee, this center of mass, if it is outside the base, when I am bending down, then it is coming within my base. Okay? Because it was outside the base, the tendency is to topple, and that is what was happening. Okay? Sorry for giving you trouble, but did you realize what's happening? Yes. So that is why it is important for you to be on stable state only when your center of mass is above the base of the body, vertically above the base of the body. And that is exactly what they did over here. They made a system so that the center of mass is somewhere symmetrically at the center and allowed it to sit on the nail. Okay? It looks as if it is very difficult. You have to think about it, but then it happens. It's not impossible. All right? I'm just showing you, this is a base having 3 spheres, and there is one small sphere attached. I fixed them all together. I want to use it as a top. How do you make a top? You do drawing and then it starts rotating. That's exactly what I'm doing. I'm going to hold this and then make it turn around. Okay? Watch what is happening. And after watching, you tell me what is happening and why. Okay? Please. It is happily spinning around it. Slowly it is becoming slower and slower and slower. Up. I did it over here, but then look at how it is sitting. I did it like this, otherwise it will not rotate. If I want to rotate it on these 3 things, it will not rotate. But I am doing it like this, so that this becomes the point of support, and therefore it will be able to rotate. Okay? I am doing it again. I am sorry. Hey. It is rotating at one of the points on the spherical body. The 3 things are giving rise to that nice spin. Okay? But the moment it stops, it immediately turns upside down. Again, you should be able to tell. What is the reason? Center of mass. The center of mass of a body, of a system of things, it always is closer to the heavier side. When I am talking about a symmetrical body like this and all, it's at the center. But the moment I said, what did I do? I showed you with that rod. I said the moment I put this and this was the center of mass, this was the center of mass. It went closer like this. Okay? So the center of mass is always towards the heavier body. Alright. So in this case, the center of mass is towards the base. Every time the center of mass has to come to a position which makes it have lesser potential energy. So that is exactly what it is doing. When it is rotating, it requires a support, a pivot. That is why it is rotating like this. But the moment it is stationary, it wants to come back to the most stable place, and that is why it is turning like this. Yes? Okay. Are you able to understand? Yes or no? Yeah. Okay. Good girl. Thank you. If somebody is tall, I would love to have them over here. Sir, can you come? You can come. When I take this out, this is a spring. The moment I take it out, it comes, opens out. It opens out. And why does it open out? Again, gravity. Okay? So I am going to tell sir what to do. If you could stand on something, or it's very difficult to stand. Right. So I want you to leave that and let the children watch. First keep it steady, hang it half, hang it, let us say half, like this, make it steady. When I say you will leave, you will leave. The higher it is, the better. Okay? Now, no, don't shake it, try to make it as steady as possible. And when I say leave, you just put, leave your fingers, it will fall down. Please watch what is happening. Watch what is happening. You can do a little more also. Yeah, leave completely, but before you leave, I want it to be a little steady. Okay, I want a tall boy, no tall people, all, yeah, okay. When it is steady, I will ask him to leave. Okay, just watch what is happening. So leave. Got stuck. Watch carefully. What is the function property of this? It springs. It opens out. Okay. Yeah, leave, sir. Did you see what is happening? First, the spring closed down completely. For all the time that the spring was closing down, this part of the spring did not move. But after it completely closed down, it fell. Yes or no? Okay, once again, sir, please, once again. Watch again. Yes? Okay. So, for the time it was becoming a closed spring, it was constantly coming down, but this was not moving. After it became a complete spring, shortened spring, it fell down. Was it because gravity was not acting like this? When gravity is always there, but when it was coming down, it was not acting. That is why it was stationary. After that, gravity started acting and it went down. Not really. That means something else must be there. What do you think is there? Gravity is a force which is trying to pull the body down. Okay? So there has to be some other force to analyze it. It is the elastic force. Very well said. It is the elastic force.
The center of mass is
Bottom. Yeah.
So when this flips, it the center
Comes
of mass
down.
comes down here
Yeah.
itself.
So what he is telling is the center of mass is somewhere over here. So when it flips, it comes down. Center of mass comes to the lower position. Therefore, it is making it more stable. Very true. Very true. How I have made it? It's not because of the cap. This is also a cap. Okay. But when I am touching this, it is toppling over, but it is going and resting like this. When I keep this like this, did it with a little more. Okay, I've put one coin. Additional weight, I made this coin put over a thing, just fit into the cap. Therefore, this becomes even heavier. This is not that very heavy. It is after all a plastic cap, not very heavy. Therefore, it's not doing. But if I put a cap coin over here, And do with this also it will happen. Nothing to do with the shape. I didn't have something like this to show you without that. So he has realized it. Well done. Keshav, very good. Keep it up. Keep it up. Yeah. Done. Can I have a little hot water? Could you just move and find out if there is a little cup of hot water or something available over here? Ask near the pantry. Okay, if somebody is there. Okay. Come here, come here, come here. You rub it over here and show it. Here, you can show. Can you see something happening? There is something over there. He is rubbing over here, keeping it, not even touching it. Can you see what is happening? What is happening? There are two aluminium foils, the foil that he was giving aluminiums, the two aluminium foils are coming apart. Why do you think? He is not doing anything, he is just keeping it outside. There is electric charges. Anirudh wants to say. Yes, say. Very good.
So when he like rubs it, that time like the negative energy like that increases. So when he keeps it over there, the negative energy is transferred like from the blue like the cylinder to all the way down. Because of that it like moves around.
1 minute. He didn't touch this anywhere.
Yeah, but
So the negative energy cannot, oh, is it hot water? Very good. Keep it up. Thank you. Thank you. Okay. Yeah. Yes. You were telling something fairly okay. Negative energy is moving down when you said he is not touching. Just do it once again. He is just keeping it up. Okay. So there is no question of transfer. There is nothing which is getting transferred from one place to another. But something else is happening. It is inducing. Okay. Transferring means it actually moves from one place to another. It is not transferring it. It is inducing. Everything has electric and positive and negative charges. This also has positive and negative charges. This also has positive and negative charges. By nature, they are all neutral. The number of positive charges over here, negative charges is equal. Over here, it is equal. So therefore, they are all neutral. When he is scrubbing, what do you think is happening? Yes? There is electrification done, static electrification. When he is rubbing, he is actually bringing it close to each other. So the charges over here are getting, some charges are getting transferred over here. It could be negative charges are transferred over here. So this becomes positive, or it could be positive charges are, negative charges are moving from here to here. So it is becoming negative, but it is getting charged. I will not tell you whether it is positive or negative. But the moment he is rubbing, he is producing friction, and therefore it is he is charging it. So that is how charging is taking place. Okay. Once this is charged, the charged body he is keeping it close to this. When he is keeping it, this also had positive and negative charges, I told you. So this, suppose it is negative, then this surface will become positive, this will become negative. Equal charges, they will get separated out, and therefore positive charges will accumulate over here, negative charges will accumulate over there. This negative charge in the two foils will repel, and therefore they are repelling. I am not telling you whether it is positive or negative. It is true the other way around also. If similar type of charges are getting accumulated in one end where the aluminum foil is, it is going to split apart. This is a principle of electroscope. It is an electroscope. Okay. But I told you I cannot tell you positive or negative. If I do like this and if I do like this is getting repelled. Alright. How will I know whether it is positive or negative? Any idea? Any guesses? How will I know that it is positive or negative? Guess. Suppose I say I will give you this and this. Can you now guess and tell how you could make out that it is positive or negative? Turning points. See, suppose it is negative and it is getting separated. If I now give you positive charges of this, what will happen to it? It will attract. Okay? So, suppose I have negative charges over here, what I am doing, if it is having negative charges, it is getting apart. If I do with this, if it is having positive charges, then it should bring it together. But unfortunately, for this I require silk, and I have not brought it silk, so I will not be able to show you. In fact, this will also behave like this. If I do like this, then it will become negative out. Do that again. Come closer. This is also separating. Okay, I should have brought a silk material. I forgot to bring it, and therefore, with silk, if I had done it, then you would have seen once it is separated out. If I do with this, it will come down. Okay, it will come like this. So you know that they are I don't know whether it is positive or negative. I simply know they are opposite charges. I can't say this is negative, this is positive. I can only say that they are of opposite charges. To find out whether it is positive or negative, you have to do a little more. I will not tell you right away. Okay, you have to do photoelectricity, and therefore you will realize how it has to be done. Okay, done. Can we use the thing, electric light? Yeah. We are using it day in and day out. Everything you have seen it right across you. Tell me when you want to stop. I don't know when your lunch break is. When is your lunch break? Pardon? We can have another half an hour? Yeah, okay. Yeah. Should not get bored. Okay. You want to try? Or I think I'll call somebody else. Come, come. Please, I want another girl to come. Somebody. Another 15 minutes I should wind up. Yeah. Another 15 minutes I'll wind up. Okay. They are getting ready for lunch probably. Okay, now I have two different bulbs. I want one of you to come. One of you to come, please. Sit down, Peter, sit down. Can I have one of you to come? Nobody is willing to come? No, they are not willing. Can I put a thing? I want to put this. This is a 100-watt bulb. This is a 40-watt bulb. Okay. I want you to put the 100-watt bulb over here and the 40-watt bulb over here. Yeah, yeah. This is 100-watt over here. Yeah, yeah. Okay. No. Okay, okay. Shall I'll have. Yeah. Sorry for troubling you all. Hot water is there. I should have shown this first. Yeah. I don't want the hot water to become cold. Yeah. Pardon? It will become cold in no time. I can't show you. I want a plastic container. That plastic cup. Wait, we'll use this. Okay. I'm putting some hot water over here. Hopefully you can see it. I want to show you this before I go. Just hold on, it will fall off. Okay. I've got a spring over here. Okay. Can you see? I don't know. I'm stretching the spring. What did I say? When I stretch the spring, there is an elastic force acting upon it. Okay. The elastic force will try to bring it back to its original condition. But here I have applied a stretch. so that it cannot act by itself. The spring is not coming down to by itself. Is it coming down? I have stretched it. All right. I am just putting it in hot water. I hope you can see it. Please see what is happening. I am putting it in hot water. Did you see that? I am stretching it, happily keeping it bigger than its actual size. I am putting it in hot water. Plain hot water, nothing else. Warm water, in fact. It's come back to its original position. Okay? What is happening? Yeah. Yeah. Never mind. Done. Thank you. I think put back this hot water, it will spill otherwise. What do you think it is? Huh? Don't know. It is called nitinol. Smart material. Have you heard of smart material? Material which behaves as if they have a memory. So this was having an original shape which was like a spring, a tight packed spring. When I stretched it and put it in hot water, it had memory. It remembered, oh, my natural state is not like this. I will go back to my natural state. And it went back to its natural state. So those materials which are behaving like this as if they remember their history or they have a memory are known as smart materials. Where do we use these smart materials? Any idea? In your iron box? No. Many children now, if they smile, you'll see something on their teeth. Braces, they are made up of this material, smart material. What is it doing? It has been trained to have a particular shape. Okay? So your teeth is probably putting pressure and it is expanding it. But by natural, it wants to come back to its original state. That is why it is contracting and coming back or bringing your teeth along with it. Okay? It is used in surgeries. You've heard of heart attacks? You've heard that they put a spring over there in the artery because the artery was collapsing. Yes? Stents. Have you heard of it? That also works like that. They will put one wire through your artery wherever there is a block. Our body blood has a particular temperature, normal temperature, which we call it as a body temperature. At that temperature, this wire will become form of whatever shape it has originally has, which is a spring, and it will coil and go sit over there. So happily it will sit and it will put pressure on your walls, because every time your blood is going to be at that same temperature. So it continues to be in that same temperature. Okay? And it comes back to its original. So these are very, very smart materials which behave in a particular way, and therefore they are being harnessed for proper engineering. Okay? Right. Now I wanted to, yes, sir. Yes, please.
You spoke about braces, right? Doctors recommend to eat ice cream after you get braces. So the metal expands to give a little bit of relief to your jaw. So is that also considered like memory? For the
No, actually if I know well, I am not very sure about ice cream. Any teeth problem you have, you pull out a teeth, they will say you eat ice cream because it heals. At lower temperature, healing is faster. Maybe because of that they will be asking you to eat ice cream, but I am not sure whether it is
metal that they use when you put something cold, it expands for a little while, so it gives much more relief for
by
a
short time. Okay, that means immediately you don't have too much of pressure on your teeth. Could be. I am not sure about it, but very good. She is suggesting something. She says if you put a brace, suppose you have gone to the doctor and the doctor is adjusting your brace. First time you are doing it, doctor is here. Sir, please tell us. Please tell us. Yeah, beautiful.
The purpose of ice cream is to decrease the blood supply so that the bleeding will be less. Second, it decreases the nerve conduction so that pain is also there. That's all.
Okay. So two good reasons for eating ice cream. Who wants to eat ice cream? Go to the dentist. Right? So, doctor has told us two good reasons. If you eat ice cream, then the lower temperature decreases blood flow to that open area. Wherever surgery has been done or something like that, blood flow will not be there. So, blood flow is not there, obviously it will become little more insensitive, you will not feel the pain. Okay. And secondly, sir suggested even your nerve endings relieves pain because of the lower temperature. So, good reason for going for teeth extraction. Okay. Thank you, sir. Thank you very, very nice way. There are many, many such simple methods of curing yourself. And we really feel very good when we hear of that, okay, lower temperature, lowering the temperature itself can relieve you so much. So, why not? Correct? Okay. Now, what we were doing, I told you that put two bulbs. There is 100 watt bulb, the smaller one is 100 watt, bigger one is 40 watt. I am asking her to put, there are two sockets, I am asking her to put over here. 100 watt over here is this one, this one, this one, over here, press it down. I am sorry. And put it over here, this one. Press it down and turn it around. Yeah. Okay. Now I have got a switch over here. Switch it on. I think it is on over there. Yeah, it's on. Switch it on. This one is on. What happened? No. It's on. No. One is not button. No, it's not working. Probably there is some wire has slipped out. I'll just see behind. Has it come out or what? No. It's perfect, sir. Yeah. Yeah. Please look over here. This was your 100 watt bulb. This was your 40 watt bulb. What do you mean by 100 watt or 40 watt? The power that is consumed by it. A 100 watt bulb should glow more or less? More. A 40 watt bulb should glow more or less? Less. But what's happening? 100 watt bulb is over here, 40 watt bulb is here. Got my point? Okay? 100 watt bulb is over here, 40 watt bulb is here. 100 watt should glow louder. Is it bright enough? Not bright. Okay? Now I'll switch it off. Switch off this one. Yeah. Take this over here and put it. No, you could press it down. Yeah, press it down and then. You'll get a shock. Now this one. Yeah. 100 watt bulb is here, 40 watt bulb is here. This is 100 watt, this is 40 watt. Which is brighter? 100 watt. So 100 watt over here becomes brighter. 100 watt over here becomes dull. What is the reason? This is a parallel connection. This is a series connection. Do you understand what is the meaning of series connection and parallel connection? Okay, very good. So when it is parallel connection, a 100 watt is a 100 watt, a 40 watt is a 40 watt. Okay, both of them behave the way it has to behave. A 100 watt becomes brighter, 40 watt becomes less bright. Okay, but when you put it in series, the 100 watt and the 40 watt are behaving differently. Any suggestions why? Yes. Pardon?
First takes up like all the 40 watt, whereas the remaining current is like sent on to the 100 watt. So because of that, the 100 watt like glows very less.
you are going a little away. You said that they are in series over here and parallel over here. Do you understand what is parallel and series connection? Parallel connection, there is a bulb over here, there is a bulb over here, they are connected like this. Okay? Series connection means there are two bulbs, you are connecting one to the other, and then to the mains. Okay? Now, Anuruddha is telling that the current that is absorbed by
the first bulb in series is more than the second bulb. Because of that, the first bulb managed to blow, but
current,
second bulb does not get enough current.
current, I want you to correct it. When it is series, current is the same. When it is parallel, potential is the same. Again, I am repeating, when it is series, current is the same. Whenever it is in parallel, the potential difference is the same. So, in this case, the potential difference over here, we will switch it off because it is creating too much of heat. The potential drop over here is equivalent to the potential drop over here. Okay? Therefore, it has been designed like this so that both of them will behave. A 100-watt bulb has lower resistance, a 40-watt bulb has a higher resistance. Please note, a 100-watt bulb has a lower resistance, a 40-watt bulb has a higher resistance. Okay? When resistance is high, current will be low. Okay. Power is equivalent to V squared by R. Voltage is the same in both the cases. So, whichever has lower resistance will be brighter. 100-watt bulb has lower resistance, therefore it is brighter. This is having higher resistance, therefore it is duller. Is that clear? The same bulbs have brought it over here. Resistance does not change, it is a part of that material. So, when I am bringing this over here, the current is the same. Current that is flowing through is the same. But this resistance is low, this resistance is high, this resistance is low. 100-watt bulb, resistance is low. So, when I bring it over here, resistance is low, therefore, voltage will be low. Resistance is high, voltage will be high. Current is the same. Ohm's law. Okay? One thing constant, other how it changes. So, because the resistance is high, voltage is high, therefore, it is behaving with as if it is a brighter body and therefore, it is illuminating more. Did you get my point? Okay? Anirudh, am I clear? Okay? Current is the same. It is the property of the bulb itself, which is why it is making like this. Whenever you use bulbs in your home, all your connections are parallel. Okay? Because they are parallel, they have been designed to work at 220 volt or whatever it is. Therefore, they are doing whatever they are supposed to do. Had you connected it in series, then this is the problem you would have. Okay? Good girl. Keep it up. Keep it up. Many a times, this is a natural problem for competitive exams, and people make mistakes saying that the other way round, and therefore, I wanted to make your concept clear. Did you get the feel of it? Can you get the idea of what is happening? Yes? Okay. I think they have told me very clearly that I must stop. So, I must stop before I go too high, too long. Okay, we will have one music and then we will stop. Okay. Where is my rod? Yeah. I will do it instead of asking somebody. I am just taking this thing, producing a small sound. Okay. Oh, sorry. What's happening? What's happening? It's getting louder. Is the frequency changing? Is the note changing? No. But it is getting louder. Okay? How is it happening? Can you feel that sense of Om over here? Yeah. So what's happening? Something amplitude becomes louder. Why does it become? Resonance, very good. But resonance is a phenomena where something has the same frequency as something else. Here I have no something else. I have something else, so I want you to tell me what is that. I am producing sound over here, this is producing the sound. So what is resonating? This is obviously not resonating. So what is resonating? It is the air over here which is resonating. Okay? So as Anirudh told very beautifully that there is resonance happening. So when I am doing this, the air inside this cup is resonating. It is because of the shape of the cup, it is getting multiply reflected, reflected over here, reflected over here, reflected over here, reflected, and that is what is making the sound persist and louder because it is resonating. So this becomes a resonating cavity. All your instruments, Indian instruments with a big hole is behaving in the same manner. Okay? So thank you very much for your patient hearing. I think I should stop and honor their words. I will not show you. Thank you very, very much, sir.
Thank you very much.
One more announcement I will do before we can close. Okay? Sir told that I am a coordinator of Anveshika, Mani Anveshika. I hope you have heard about H.C. Verma, professor of IIT who has retired, and he has led the country. The whole country is now undergoing an experimental competition. This is one of its kind. You always have a theory competition. You have theory tests. Everything is writing question and answers and answering multiple questions and getting. Here you have to do some experiments on your own with help of course, and then give your results, and we are trying to make you more skillful in experiments. This is an examination called the National Anveshika Experimental Skill Test. It is on. It is going to happen very soon. It is a 4-level test. First level will be a video of experiments. You have to give multiple choice answers and clear that. That is going to be totally online. And then those who are selected in the first level will go to the experimental skill test. We will give you some ideas. You will do the experiment at home. How will you do? You don't have apparatus. You have to design your own apparatus and then do it. Not the big sophisticated apparatus, something simple with balloons, with glass, with water and things like that. Fantastic experiment. You will design it all yourself and then report whatever you have calculated value. Then based on that we will do a online verification and then qualify you all for the next level. Okay? All those who win in that experimental test will get regional prizes which will be given for each region. We have 36 regions all over the country. Each region we will be giving first, second, third prize separately for school children and for college children. So all of you are eligible. It is totally free of cost. You don't have to spend a single pie. You have to simply register and then you have to sit for the exam. First part is online, second part is experimental, which you can do it at home. Okay? And you get prizes. And the best part is those of you who have got prizes will be called for the semi-finals and finals, which will be conducted on site in Kanpur under the supervision of Padma Shri H.C. Verma. He has a beautiful ashram where you will be accommodated and you will do these experiments under his guidance. They will be keeping a watch of it. The advantage of these experiments are it is very simple, but it requires your ingenuity to be able to do it, not quickly. They give you the whole day. If you cannot complete it, you must complete with help, without help, before you can leave, so that you learn the experiment. Okay? And there is no registration fee for going and coming to Kanpur. You will be given all the fees, etc., etc. There is big money. Semi-finals, if you win, then you go to the finals. It is being done for 2 streams, college students, BSc and MSc, and class 9, 10, 11, 12 together for school children. Okay, prizes are exorbitant. You will get first prize 20,000, and after that scholarship 80,000 per year for 4 years or 5 years, whatever you are doing. Please keep that in mind. Anybody who is in 9th, 10th, 11th, 12th can participate. All that you have to do is go to the website nest_shiksha.sopan@org. Okay, I think I will show that thing. Sir, I have given you in your WhatsApp. If you can just display it, copy down that, go home, and then you register. Registration, very few time is there. The last date was announced as 20th May. As of yesterday, we have extended it to 25th May. So today is 16th. Very few days are there. Take up your willingness. I will do it, and then you go and participate. All of you are eligible, all of you are welcome. Please participate and get the fun of it. The whole experimentation process is novel. Nowhere in the country, anywhere in any big institute you will get this experience. You will miss something if you don't participate. Okay, so I am wishing you all the best. Please do participate. No preparation is required, no extra studies is required, no money is required, nothing is required. Only your time and effort is required. So please do participate. Okay, pardon? 8th standard, we will not allow them to participate now. They are too small. So suddenly they will get into that and not do well. They will get disappointed. So next year they will not like to. Encourage them to join next year. Every year we are having this. Okay. So that is all about Amani Anveshika. Amani Anveshika is one Anveshika in Bangalore, which is catering to full Karnataka, where I am the coordinator. But there are many such Anveshikas all over the country. Some 29 or 30 of them are there at present. Okay, so we do experimental demonstrations. Okay, bye. And
Thank you
we
very much.
tend to teach you all, not just to show and go away. It's not magic. Okay.
Thank you very much, ma'am. A big round of applause to ma'am on behalf of KSTA.
Thank you.
Now we will have one more session by Dr. Shyam Sundar sir. After that we will be leaving for the lunch break. Is that okay?
No sound.
Is that okay?
Probably I gave them a wrong idea. I said lunch is waiting for you. That's why.
No, are you comfortable? No, you need a
You
break.
need a break?
Sir?
No. Sir has to go to Mysore, so I think it's better to. Thanks for your cooperation.
Personality. Please.
Now I request few students to help volunteers for ma'am. Also now I request our colleague Srinivas sir to introduce Dr. Shyam Sundar sir before starting the session.
So, good afternoon, one and all. So, today we have Dr. Nonavinekere Mannar Samasundar sir, NM Samasundar. Sir did his BSc, MBBS residency in pediatric surgery, MSc anatomy, MI, SF, SP and FFBP, PhD, all the education from primary school to PhD level, including the job and services in Mysore. He did BSc and MBBS with Government of India National Merit Scholarship without spending single money from his pocket. So, presently sir is a professor of anatomy, JSS Medical College, Mysore, and former dean, faculty of Biomedical Sciences, JSS University, Mysore. Working in JSS Medical College since 33 years as HOD for 16 years. Family physician and practicing pediatric surgeon since 33 years. Sir is teaching of MBBS students, BDS, BAMS, BPT, BSc and MSc, nursing, speech and hearing, and technologist, DNB, MD, MS, MDS, PhD anatomy courses. He has attended more than 50 and presented papers in the state, national and also international conferences. He has published more than 50 peer-reviewed articles in both in national and international journals. Sir, areas of interest is health museum for students and public in the Department of Anatomy, and plastination, established the first plastination museum in India. A neuroscience research, depression brain bank, second in the world, and created first Alzheimer's animal model, ear ossicle bones transplantation bank from dead people for grafting to hearing impaired patients. Sir has conducted more than 5,000 operations almost free, taking only medicine charges to poor and needy people since 33 years. Sir, general practice cost patients only 10 rupees, including medicines. So please give a big round of applause. So salute to you, sir. He has started a JSS Body Donation Association in the JSS Medical College for 23 years ago, and has record registration of more than 3,000 plus people for donation of their bodies. More than 360 bodies already donated, highest number in India. And his family has also donated the bodies of his mother and sister to the medical college and have been plastinated. Sir also got several awards for his more than 50 to 60 awards for his service. Best Teacher Award at JSS Medical College, member of International Society for Plastination, Brisbane, Australia, UGC a National Award for Plastination as Best Program for Teachers, and Karnataka Chapter for Anatomist Gold Medal for Depression Research, and felicitation by Divisional Commissioner of Mysore, Pride of Mysore Award by Pragati Pratishtana, felicitation by Lions and Rotary Clubs Bannur, Seva Ratna Award, Samaja Seva Ratna, Vaidya Ratna, Lifetime Achievement Award, Best Science Communicator Award, Indira Gandhi Gold Medal Award, and Bharat Jyoti Award by India International Friendship Society Delhi, and Best Paper Award, Visiting Faculty Lecture in IBRO sponsored International Neuroscience Workshop in Sri Lanka, established the Plastination Museum, and received project from RGUHS, JSSU, DBT, DST, and also international grants, and many more. And a regular speaker in TV channels, All India Radio, writes articles, magazines, and newspapers, given hundreds of lakhs in schools, colleges, and social organizations. Sir has visited Singapore, Malaysia, Sydney, Brisbane, Athens, and Azman, all in Dubai, Croatia, Sri Lanka for research on plastination, depression, and suicide, brains, scoliosis, basic molecular and DNA studies. Sir also got several hobbies like arts and crafts, electronics, carpentry, music, TV, radio, and also print, technical talks, articles, and communication and cooking. With this brief introduction about sir, my own behalf and KSTA and all of you, RT welcome you, sir, and also thank you very much, sir, for accepting our invitation to give a talk on this session. So once again, salute to you, sir, your kind service to the humanity. So thank you, sir.
Wish you a good afternoon. I can understand the stomach is empty. Being a doctor for 43 years will not take your time. My friend has taken more time probably introducing me. I'll take less time. I really expect your excuse because I have to go back to Mysore. Evening I've got surgeries. I operate on a lot of people, very poor people coming from villages. So I've already fixed up the surgery. I had to rush back. So I request you to be a little more conservative about your stomach for some time. I was particular to show and go because all the things that are kept on the table are real. They are not models, right? So just rush through. No questions asked like madam. I will answer the questions. Can I have these lights off, please? Maybe one or two lights. So I just rush through. Anywhere you want me to stop, I can do it. So when I put it, somebody said it's not morning. When we meet on the first time, I can always say good morning. There's nothing wrong in that. So welcome to the city of Bangalore. I'm from Mysore, the beautiful city of palaces. Let's learn to see the beauty in everything. I see beauty in everything, right? My profession is social service, seeing the patient tomorrow morning better because of my treatment, saying that I'm better, that's my purpose. So this is the beauty of Mysore Palace when you see it during the night times and weekends. Let's try to, all this I will just jump over. My concern is two. One is to show the real specimen. I got not able to hear. Echo is there? Yeah. Okay. Is the last bencher able to hear me? No, yes, don't know. So two things. One, try to be healthy. Most important asset is health. Lot of money, lot of assets, absolutely waste. You're healthy, you're fine, right? So a few tips to keep your body healthy. As long as you want to live, you can live for 100 years. But you have to have good habits. Second is to show the real organs. I've got the brain here, here also. I got the heart, I got the kidney, I got the baby, real babies. So show them. They can also come down after the talk. We'll so all these things I've seen already. Most important, as madam said, attitude is important. Positive attitude. Everything is great in this world. Everything happens for good, right? Have the positive attitude. When you take an examination, you are going to pass. Who else other than me can pass? That attitude, you will definitely succeed in your life. Have self-confidence. Have a saying that I can do it. You'll do it. So instead of me, let's have a team, we. Successful people have a smile and silence, you know the reason. Smile takes less energy, needs more muscles. As a medical person, I know the muscles in the face. For smiling, less energy, less muscles. If you want to be angry and shouting at somebody, you'll be wasting your time, energy, good relationship. Stress is the most important thing, starting from a simple headache to cancer. Stress can cause cancer. So try to avoid the stress. Successful people are doing something different way. That's all, not different things. So try to do the things in a different way from a different angle, right? Happiness is not money. Happiness is not asset. Happiness is only seeing others happy because of you, right? So stop comparing, criticizing and complaining. You will be happy. Others also will be happy. William Shakespeare said, I always feel happy because I don't expect anything from anyone. So it can always be happy. Madam did not give you this one, that fellow did not give you this one. When you go on complaining, you will never be happy, nor the other people will be happy. So your health is in your hands. Don't blame anybody for your bad health. Your habits, your food habits, your lifestyle, your mind is in your hands. You got a health museum in JSS, which I have established almost 40 years back. When you come to Mysore, you can always visit. If it is a big group, maybe expect you to write a letter. If it's a small group, it can always take you around. It is one of the best museums in India. So this is the huge one, hundreds of specimens, all parts, starting from brain to kidneys. So recently we got a little renovated with the new lightings, new tables and all that. But it's one thing very beautiful. A lot of school children come here. We take them around the museum, show them around. Any questions asked, we will try to clarify to them. So these are all my colleagues. I'm there somewhere there on the left, right. So like this, children from schools, government school, private school, everybody is welcome. So we have specimens like this. I have collected from different hospitals when they died at the time of birth. Some of them are twins, some of them have got abnormalities, a few of them are brought here also. So different organs, a few of them quickly we'll try to know what is the importance. This is a baby, small baby. I got a baby here, few months old baby. He is about 5 weeks. When all of you were there, hardly 1 month and plus, you were like this, like a small rat. So heart is the most important part according to me, because that's the one which has to supply oxygen and nutrients to every part. If heart stops, the person is going to die, If brain stops, still one can be live. Kidney stops, still one can live. But if heart stops, the person is going to die. So take care of the heart. No stresses, no bad food, no junk food, most important. Yes. But the heart also, you can even touch the heart. That is a specialty. Kidney is the next housekeeper. Takes up all the unnecessary material from your body, throws it out as a urine. So keep your food good, kidney will be happy. Liver is another big factory, is a food processing factory. More than 100 functions. Whatever food you eat, vegetarian, non-vegetarian, good food, bad food, it has to process. Poisonous things is going to filter, convert into non-poisonous things. This is the largest organ present in the upper abdomen. Alcohol is going to destroy the liver, cause jaundice, cause death. Smoking is definitely going to cause it. Viral hepatitis is going to damage it. Further lead to cancer. So liver cancers are increasing. So your food habits is going to decide your health. Muscles are the most important things. 60 to 70% of our body weight is muscle. So have a good muscle, your locomotion will be good, your movement will be good, all the parts of the body will be in a good condition. So go for a good jogging or walking, always be active. Don't try to sit with a laptop or a mobile. Sitting is the one, sitting kills you. So always be active. If you want to live for 100 years, physically be active. There are 600 muscles in the body. Some of them are small, some of them are short, some of them are big, some of them are small. All of them are necessary for various activities. I'm a family physician. I operate a lot. Since 40 years I've been operating. I've completed more than 5,000 surgeries in my clinic under local anesthesia. When I see my patient, a small kid or adult, tomorrow morning smiling and saying, I'm fine doctor, there's the money I get, $1 million, right? Money is not the criterion. As long as you have basic money for your happiness, that's it. So I'm the only person in Mysore doing so much of a surgery. This is my clinic. Villagers from different villages they come, even from Bangalore people come. So my happiness is using my knowledge and skill, if I can make a person who was suffering, who was crying, who was ill, tomorrow morning better, that's my profession, right? So I got a small museum in my clinic also. Instead of putting a TV or putting a program or showing charts, people get educated. Whatever they operate, those specimens also I keep, so that the people become aware of their health. So people come like this, a small baby with 2 fingers joined since birth. Cut it open, stitch it. So a doctor has to be a good tailor also. A doctor has to be a carpenter. Doctor has to be a cobbler. So we do all these things. So there are 600 muscles in the body. Bones are very important for support. There are more than 200 bones. Very funny thing is, when the baby is born, there are 300 bones. As the baby grows up, by about 25 years, many bones join to each other, reducing the number to 206. So all of them are so important, giving a support, giving a framework, and most important is, inside the bone is a factory. What factory? Blood producing factory, hemophysis. Without bone, no blood. Without blood, no life. So very interesting set of bones. I've got a small set of ear bones inside. Many people have the bad habit of taking a small stick, wrapping it with cotton, putting it inside and trying to clean. And after some time they say, I'm not able to hear. What are you talking? Never do it. Ear is a very, very delicate, as delicate as a watch. Any problem with the ear, go to a doctor. Because once you lose the hearing, very difficult for even the doctors to repair it. Nature has given a wonderful mechanism of hearing, so you don't handle it very roughly. And we have got the bones which are so delicate, you can understand the delicateness. So these are the small bones, the white bones. They are few millimeters, 3 to 4 millimeters. Any damage to that, permanent or temporary hearing loss. To replace, to repair is extremely difficult for us. The right one is the semicircular canals, the cochlea semicircular canals, which help in balancing, which help in hearing. So you can understand, so you cannot hear, asking somebody, people comment us, that fellow is deaf, don't talk to him. So these are very delicate organs like the eyes and the ears, be careful about them. Lung is the most important organ for supplying the oxygen. Because of unfortunate air pollution, the lung is being destroyed, being made into a dustbin. See this, what a wonderful way. I brought the cast of the lung also. Right here we got the lungs. It works 24 hours a day. I've made the cast of the lungs. Imagine this is the air, 24 hours, breathing in, breathing out. And is this place that oxygen goes in, carbon dioxide comes out. Because of the bad air pollution, smoking, traffic, the whole thing is getting black. And I'll show you, this is like a tree. It's like a piece of art, natural art. So this is the one. But see this, a beautiful white colored lungs because of the pollution and no time. And over that we are buying cancer. How? By cigarette and BDs. So anytime it can become cancer. Number one cancer in the whole world, including India, is lung cancer in men. Now men have decreased smoking because of people like me threatening them, but unfortunately the young girls have started saying that we are equal to men. In no way we are inferior to men. Very unfortunate, right? Yes. Obesity is a big problem. Very, very big problem. Childhood obesity. America, Japan and India are leading. So a boy or girl of 15 years, 18 years, 70 kg, 80 kg. Yesterday, day before yesterday, I saw a young girl of 26 years who had a small abscess here. I was looking this way because she was horizontally growing, not vertically growing. I said, what is your weight? She said, actually my weight has come down, uncle. No, I'm not asking you coming down. What is the present weight? She said it was 120 kgs, now it is 119 kgs. I was sweating. See there. And have you got your blood sugar tested? No, uncle. Yesterday when I got sugar, it's such a sweet girl, like a sugar factory, diabetic. Very unfortunate. So be careful about your fat. Do not go on eating and eating and eating. So what do we do? Sit and eat and sit. So never, you have to maintain your weight and height according to your age. Because obesity is a invitation, free invitation for diabetes, free invitation for hypertension or high blood pressure, free invitation for joint pains, and very unfortunately free invitation for cancer. Overweight is one of the invitation for cancer. Be careful about your diet. Good exercise, balanced diet is the only simple technique of. See this. Which is the front end, which is the back end, I am confused. In no way women are inferior, right? And we have our friends. Bhima has got a gade also. Yes. It's all because of this. The fellow is not even watching that. He is putting it, even empty, so watching the TV or something. So be careful about children. Children's obesity is more dangerous than adult obesity. So parents, please be careful about your children. So the heart attacks, Madam was telling about the stent and all that. Once the heart blood vessel, imagine such an important organ starts working at the age of 1 month, when the baby, so-called embryo, is just 1 centimeter, less than 1 centimeter, starts beating. Till the last second of our life, it beats without break, 24 hours a day. We have to take care of that heart because that's going to give us life. But because of the junk food, oily food, spicy food, smoking, alcohol, the small blood vessels, coronary arteries, which are smaller than the refill of your ordinary ballpoint pen, Reynolds pen. If it gets blocked, you can see the block there. It has to be operated. So who is to be blamed? It's not the doctors, it's not the hospital, yourself, your bad habits. So see the cancer, only cancer probably which can be prevented. This is a lady, uterus is there. So this is the uterus, this is the cancer of the uterus caused by a human papilloma virus. He's got a vaccine. All the girls, not after getting cancer, before that, all the girls in the reproductive age group, 10 years onwards, 2 doses, 100% prevention of human papilloma virus. All the other cancers cannot be prevented, right? So if you have the intention, get 2 doses of HPV vaccine, it is 100% preventable. So, see the smoking, 90% of the smoking cancer is due to this. Even passive smoking, somebody has left the smoke outside, same thing so alcohol damages the stomach, damages the liver, causes liver cancer. We are seeing a lot of people nowadays going for liver cancer, kidney damages. Breast cancer, number 1 or number 2. One is uterus cervix cancer, second one is breast cancer. So we are seeing a lot of, I operate a lot of cancers. Early stages of cancer, 100% curable. About 30 years back, 33 years back, I operated on a school teacher with a testis cancer. He is still alive, only day first day said, I'm fine, sir. So earlier stages, before it spreads to other parts of the body, if operated, it is 100% curable. But once it is spread to other parts, absolutely no chance of survival. So, see the breast cancer, very simple. Every day, a girl or a lady should touch the breast during the bath. Any swelling, smallest swelling, go for a mammography, 2 millimeter size, identified at the earlier stage, it can be operated, 100% curable. It is a very simple test costing a few hundred rupees. See, the liver cancer is due to bad food, junk food, and alcohol and smoking. All of them can be prevented. 1 in 78 women will be diagnosed with ovarian cancer in lifetime. Now it's increased 78 to 85%. So be careful. Any changes, don't neglect. Don't think it will come down. No disease will come down on its own. Consult a doctor with whom you have got a belief. See the ovarian cancer. Lot of women are coming. We are operating a lot, right? See the blood cancer is increasing because of the junk food. Do not eat anything in the roadside. All the chemical contamination, road contaminations. See the number of RBCs, WBCs, both the WBC cancer, leukemia, RBC cancer. Not curable, yes. Right? Communication is very important for your studies as well as your life. Balanced diet is most important. Have a good balanced diet, you can always. Pancreas is another organ which produces insulin, prevents diabetes. But unfortunately nowadays, because of again the bad food, junk food, pancreatic cancers are increasing. It does not produce any symptom, no complaints at all. One fine day, either you land up in a very severe pain or jaundice, go to the hospital, get a scanning done, you'll find the pancreatic cancer sometimes spread. Very unfortunately, one of my close friends who was a doctor, was a surgeon, did not have any, absolutely no problem, very healthy, very good surgeon, just had some little difficulty in, some discomfort there. Since a few days, little not so good taste, he was thinking maybe because of the weather, some viral infection. He went to the his own hospital, colleague's hospital. When it was scanned, CT scanned, he had a pancreatic cancer which spread whole abdomen, no symptoms, no pain at all. So such dangerous things cancers are producing. So never neglect. Even one day negligence can cost your life. See the stomach, most important organ for some people at least. Yes. Bad food, stomach cancer is increasing. This is the brain, normal brain. This is normal brain. Cataract, never neglect any vision problem. Go to your eye specialist, they will diagnose. Yes. Uterus, one of the commonest cancers is breast cancer, uterus cancer in women. So obesity, already I told you, I think it's repeating. There are so many organs in the body, what we call the endocrine glands producing hormones. All of them are unfortunately, when we were students about 40 years back, some of the diseases we had never seen, only one patient, two patients. Now almost every week or 15 days we are seeing a lot of hormone related problems, PCODs, thyroid problems, adrenal problems, all because of lifestyle, stresses. A good healthy mind in a healthy body. Keep your mind healthy. See the thyroid, the cancer of the thyroid. People neglect. See, the lady has not come to the hospital. When we ask her why you are so late, I thought it's now nothing serious, it is going to go down on its own. No disease can go down on its own. And when we open, we know it's a cancer. Spread to the voice box also, he cannot talk. See this, we are always unhappy. We compare with others. See, the boy doesn't have a leg, and the boy doesn't have a hand. We are so happy. We have everything perfectly. We have all the parts perfectly, but still we are unhappy. We are always complaining. So learn to be happy with whatever we have, right? So we have a depression brain bank. That's the only one in India, second in the world, where we are trying to analyze the cause for depression. We treat them. Depression is 100% curable. If not treated, it can lead to a lot of psychiatric problems. So we also have a ear-ossical bank, damaged ear bones. We take from the dead body, we transplant it. This is first in India and second in the world. First one is in Netherlands. Plastination is my specialty. routinely you see in a museum, botany museum, zoology museum, medical college museum, a bottle of formalin. So no bottles, no formalin. They're all dry preparations. Incidentally, I'm very happy and proud to say that I'm the only person in India, second in the world, to design this technique. They are purely hobbies. I've got a lot of hobbies doing all funny things. So it took more than 10 years or so for designing this. Most of the time I carry things in my pocket. I tell the people, ask the people, where is the baby? Baby will be in the uterus. Sometimes I take it out from my pocket. Shamsundar's baby is in the pocket. So this is real baby. 1.25 month, 5 weeks baby, yes. You can see them later, just quickly go through this. This is the real uterus. One of my classmates is a gynecologist. He operated hysterectomy. People think when we say your uterus is, there's a problem, there's got a tumor, there's got a cancer, we want to remove it. Women think whole abdomen is uterus and abdomen will become empty. No, it's only a small one, right? It hardly takes about 15 minutes. So don't be scared. Doctors are for your good, get it operated. So a lot of stones are seen in our body. Not the stones that you find in the roads, but the stones in the different regions. The kidney stones, gallbladder stones, stone in the pancreas. Even if you do not pass motion every day, the whole motion can become hard frequently. So have a good habit of passing urine in motion and good habits, right? Yes, whatever comes to me randomly. This is the cardiac pacemaker. All of us have got a stabilizer on the top of a refrigerator or in a TV. Whenever the voltage goes up or goes down beyond the limit, it's going to produce a current and stabilize the voltage. Exactly in the same way, when the heart rate goes beyond 150 or 160, comes below 60, this is going to produce electricity. This is put under the skin and the waves are going into the heart. It's a demand pacemaker. This works for 15 years. For mobile battery works for only 3-4 years. This sealed battery, lithium-ion battery, works for 15 years. So person who has got a chained electrical signals in the heart, we transplant it. It was lakhs together, now it's hardly about 60 to 70,000 rupees. He can live for another 15 years. After 15 years, again some problem, take it out, put a new one. So it's something of a technology, great technology that we are able to manage people. So I have a lot of hobbies, I told you. With ordinary snail shell and a few tubes, I prepared a model of the inner ear. If you want to teach the school children how the inner ear works, about balance and about conversion of sound into electrical signals, I make these ones. As I was traveling to Bangalore the previous 2 months back, I made it in the train. So we got very small ear bones, very minute ear bones. You can come and see later if you are interested. Yes. The eggs are the human egg. You have seen the hen's egg. You have seen many other eggs. Human egg is just a dot, 0.1 millimeter. It may be so difficult to see also. Just a 0.1. And that contains all the information about my mother, my father. Software, genes. What height I am supposed to be, what color I am supposed to be, what type of a hair. Wonderful, isn't it? Software. So you got a pen drive and CD drives and all that, such big ones. But all the, every millimeter, how my nose should be, tip of the nose, side of the nose, every information in a DNA gene is present in such a small 0.1 millimeter dot. This is a human egg, right? So like this we have lot of things. The genes on the chromosomes are like this. There are thousands and thousands of genes. There is a gene for my hair size, straight hair, curly hair, genes for my color of the hair, genes for my eye color, tip of the nose, how many years I have to live, everything is already there as a software. So make some models like this. There are all, yes, a few things I have to show you. This is the stomach. Probably all the stomachs are empty now, cursing me also. This is the stomach, always going to be filled up in about half an hour. This is the heart which is there. Yes. You can always say, I have touched the heart, somebody's heart. This real baby, about 5 months old baby, has got a placenta, is a baby. Yes. There's a kidney which is going to keep your body clean, right? There's a lung, become black because of the air pollution. This is half of the brain, most sophisticated computer, supercomputer. No computer can compete with this. You press a button of a computer, it takes some time, irritating circle, isn't it, to open the file. But this, with a fraction of a second, can go to some other file. So all these things are real ones. Quickly, okay. There are stones in the kidneys, yes. Only day before yesterday I operated on a small lemon-sized stone in the urinary bladder. And this was in a small baby, about 3.5 years old child. So like this, there are so many things, very interesting. Health is the most important thing. Plastination is, because nobody had done in India, I was the only person. I had the privilege of 1988 or something like that, have the cover page. The baby is also plastinated. So mummification is similar to plastination, more sophisticated. So this is the mummified baby. You have seen the Egyptian mummies in the pyramids and all that. I've created one, it's in the college. So even the animals can be plastinated. You can carry in your pocket a real snake plastinated, of course dead snake, the rat snake, the cobra, see the cobra. And all these were in my college. They brought me. They were dead and brought it to me for plastination. Inner ear, in the scorpions. Very interesting point I have to tell you. I go to the schools and colleges, hundreds of them. I even go to the summer camps where LKG, UKG fellows, very dangerous fellows. So they ask very funny questions, very difficult to answer. So I asked them, I showed the real scorpion and showed. And very small boy was sitting there. Uncle, I want to answer. Yes, please, very good, very nice. What is your name? XYZ. He said, what is it? He said, cockroach. I was shocked. Cockroach? Why there's a tail? That's what I'm also curious, doctor. Why your cockroach has got a tail? My cockroach doesn't have a tail. See, if I had not taught them, it's not cockroach, it's dangerous scorpion. In the encoded that they get bitten, right? So education is very important. So even the plants can be plastinated. Yes. You're the architect of your future. Try to design your own. I've got a team of people for research, for different types of research. I'm involved in international collaborative research. We get a lot of funds from DST, DBT, and so many other organizations. If you want to do, there are 100 ways to do it. If you don't want to do, you can always sleep. So creativity is mine. I have a lot of hobbies. If you have hobbies, cultivate it. Instead of putting all of them together, somebody arranged this so nicely, isn't it? You can do it. Yes. This is my colleague. The lady is a cardiologist. She's got a painting instead of putting a flower or something like that. Husband is a neurologist. See, for a marriage, so nice. And teamwork is important, right? I get all this in. The biodata I had given was a little older one. It says some 50, 60 hours. Now it crossed 190 hours. You can get more of it. Nothing special. Do the work to your satisfaction. You cannot satisfy anybody, including your own family members, husband or wife. To your satisfaction, do the work, automatically all the awards will come and happiness will come. It's not the awards, it's happiness. So I got the Government of India National Merit Scholarship right from 10th standard, PUC free, BSc free, MBBS free, MS free, no, nothing to spend. So all of wonderful students are there. Work hard, you take it as a challenge, you will get a lot of good things. A lot of children come to the museum. Because I educated myself to become a doctor, free of cost from government, I thought I should give it back. My father was a veterinary doctor, not a human doctor. So in his name, Dr. Mannar Krishna, I have instituted a gold medal to the student, my student, MBBS students since 28 years or so, who gets the highest marks in my subject. So my hobbies, yes, this is interesting. I do sing, I do play mandolin, guitar and harmonica. Arts and crafts, I make dolls, very interesting. Carpentry, a lot of carpentry. If you come on a Sunday, you'll have to ask who is Shamsundar doctor. That has been a very bad shabby dress. Electricity, electronics are my hobbies. A lot of instruments I design, low cost instruments. Health education, go to TVs, radios, whoever calls me, I go there without hesitation. Last one is interesting, cooking. I do a lot of cooking. I go to, see this, in the college, I get involved in the cookery competitions. Yes, all these things are nice, mouth watering, the food in the lunch time. These are the dolls which I made in final MBBS. I got the first prize naturally, isn't it? And a doctor can do such things, you can do nothing. This was my mother, very, very active, hyperactive. She is no more. 2010, she expired. Till the last day, believe me, till the last she was active. No hypertension, no diabetes, no obesity, no problem. She was very, very happy. As my mother's education was only 7th standard, LS, lowest secondary. Her philosophy was very simple. As long as you want to live, be happy, be active. Once you become unhappy, once you become lethargic, you're going to die. So she had a small problem at the age of 93, she died. So her body has been donated to my college, her body has been plasminated. Even today I'm able to see my body, my mother's body after 13 years, 2010. So her body has been donated and plasminated. So lot of power, I think those things are not necessary. Thank you very much for your patient listening. If you are interested to see, please come. Thank you. Still, in case you have any questions, I'll be too happy to answer them.
Sir, it is really amazing, sir. So very much interesting lecture you have given, and you have given lot of insight regarding not only human bodies and health aspects. You created some kind of happiness among all of us. So thank you very much, sir. So for your wonderful lecture, sir. Thank you, sir. Thank you so much, sir, and thank you for your wonderful service you are giving to the society. So thank you, sir. And we have a lunch break for 30 minutes. So please come and see the models one by one, and
row by row,
just
row by row.
one row, first row, and like that.
ವೇಟ್ ಮಾಡಿ ಸ್ವಲ್ಪ ನಿಂತ್ಕೊಂಡು ನೋಡೋಗಿ.
ನಮಗೆ ಅದು ಇದು ಗೊತ್ತಿದ್ದಿಲ್ಲ, ನಾವು ಮನೆಗೆ ಹೋಗೋಣ ಅಂತ ಹೊರಡೋಣ ಅನ್ಕೊಂಡಿದ್ವಿ. ಆಮೇಲೆ ಇವರು ರಮೇಶ್ ಸರ್ ನಮ್ಮ ತಂದೆ ಜೊತೆ ಮಾತಾಡ್ತಿದ್ರೆ ಅವ್ರು ಬನ್ನಿ ಹೋಗೋಣ ಅಂತ ಕರೆದ್ರು. ನಾವಿಲ್ಲ, ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಎಲ್ಲ ಇಲ್ಲ ಬನ್ನಿ ಎಲ್ಲರಿಗೂ
Welcome back to the afternoon session. Very good afternoon to one and all. Now we have with us Dr. Keshav Bulbule sir. Yes sir. Before starting this session, I would like to give a brief introduction about Dr. Keshav Bulbule sir. Sir has served as a professor of chemistry for 37 years in KLE Society, S. Nijalingappa College, Bangalore. He has received his PhD from Kuvempu University for the thesis on recovery of metals from the end of life personal computers. He has visited many countries like Kuwait, USA, Japan, Singapore, China and Belgium to participate and learn the latest environmentally sound technologies of recovery of precious metals from printed circuit boards. Sir has published many research papers in collaboration with E-Parisara, India's first approved e-waste recycler, Bengaluru, and EHAM University, Japan. He has scripted, directed and produced 10 professional quality innovative audio-visual documentaries which have reached several thousand teachers and students. Sir has done many social works, trained hundreds of female prisoners of Bangalore Central Jail to prepare detergent powder, candles, chalk pieces and incense sticks. Sir has received many recognitions and received many awards, out of which he has received Sigma 11 award presented by Srimati Sudhamurthy, Chairperson Infosys Foundation, for the best article on Buffalo 2 Mridangam, and State Outstanding Teacher Award presented by VGST, Government of Karnataka, for innovative methods of teaching. Sir has also received Tata Chemical CII Award for promotion of chemistry and chemistry with human touch, presented by Dr. Shashi Tharoor, Union Minister for Human Resources, by then during 2012. Since 2014, Sir has been serving as technical consultant for a Government of India funded mega project on environmentally sound methods of recovery of metals from PCB. With this brief introduction, I welcome you once again, sir. The floor is yours. Thank you, sir.
Thank you. Good afternoon. Cannot hear. You all had lunch? Enough lunch? The chair should have been proportional to the lunch that you had. Good afternoon. I know that afternoon sessions are little lazy because after lunch starts working. Understood? Therefore, activities taken in the afternoon session. Otherwise, morning hours are very good for theory and afternoon hours are for activity, and therefore I requested KSTA to have my session in the afternoon for two main reasons. Number one, activity will keep you awake. Number two, certain items that I purchased today morning while coming only to this campus are not that stable and cannot be used after say 5 or 6 hours. For example, liquid nitrogen we purchased about 6 liters, and if the container is kept as it is till say 7 o'clock or 8 o'clock in the night, only container will be there, liquid nitrogen will not be there at all. So also dry ice, liquid nitrogen is at minus 177 degrees Celsius, right? It has to be carried in a very special can called cryo can, and dry ice, which is at minus 77 degrees Celsius. We purchased a big cake of 10 kg. I don't know whether 5 kg is left or 2 kg is left. We purchased at 12 o'clock, right? And that is the reason why normally I prefer afternoon hours, so that same day morning we can buy certain things and make a demo, effective demo related to the theory part which have been taught in the theory classes. And at the beginning, I thank KSTA. I thank specially Madam from Maharani Lakshmi Ammani College. In fact, she does not have any session in the afternoon. We met each other during lunch hour, and I just told that there are very interesting experiments. Then Madam volunteered to stay here. Madam, thank you for inspiring me being in the front line. And I want to know how many of you are studying in, all should be active here, not there with the mobiles and all that, right? The KSTA has spent lot of money to make one experiment successful, would have rehearsed several times. Though the same experiment has been demonstrated several times, we spend a lot of time in preparing this mentally and physically, and it is all for you only. Government of India and Government of Karnataka is doing it for you only, so you should make the fullest use of the opportunity provided by KSTA, and therefore I want to know in the beginning how many of you are studying in 11th and 12th classes. Just raise your hand. Raise your hand. Yes, good. Then 10th, right, and below that 9th and 8th. Anyway, it is heterogeneous. Experiments are so designed that even a layman can understand. One need not have studied 8th, 9th and up to 12th. And my motto from the beginning is theory guides, practical decides. And when we talk about sir, okay, yeah, you just look at this great man's statements. I am not reading all the statements. I will focus only on the third paragraph. This is okay. Can you read this? Right? When a principle learnt in the classroom is borne out by practical experience, it creates a strange sense of excitement akin to unexpectedly running into an old friend among a crowd of strangers. What pleasure and joy you will have when you meet your LKG friend, UKG friend, not immediately, but after a gap of say 10 years, 15 years, that pleasure cannot be described in words, right? You will not have good vocabulary to describe that joy. That joy will be there when you see an experiment for which the theory has been taught to you by your respective teacher in the theory class. And this statement inspired me a lot. Then I thought, why we should not design very simple, locally available, readily available materials, use them and see that theory is taught in a proper way. Seeing is believing, not vice versa. Fortunately, you are so good that you have been believing teachers, but it does not mean that you have seen the experiment. We write an equation, for example, ammonia oxidized to nitric oxide, then nitric oxide oxidized to nitrogen dioxide. Nitrogen dioxide dissolved in water, use not only nitric acid, but also nitric oxide NO regenerated, can be reused. And we say in these three equations, first equation is the key equation. I am going to show that little later, right? Key equation, because ultimate yield of nitric acid depends upon the yield of nitric oxide. And the very first equation in this production of nitric acid is exothermic, because along with nitric oxide and water, we show that so many kilojoules of heat is liberated. We write the equation plus so many kilojoules of energy, and see there, so many kilojoules of energy is released, therefore it is exothermic in nature. The rest of the reaction will take place on its own, further heating is not required. Fortunately, you will believe the teacher and go home, you will memorize and reproduce it systematically in the examination, but it does not mean that you have seen the experiment. So such equations are practically converted into what is called visual education. Demonstration is visual education, and therefore I have designed some experiments, and you see the last statement, right? Demonstration acts as a positive catalyst. You know the difference between positive catalyst, negative catalyst and auto catalyst, etc. to visualize many abstract invisible concepts. Theory guides, practical decides, right? In fact, we'll take the very first experiment. that is based upon Joule-Thomson effect. I require the help of 2 volunteers. One 8th standard boy or girl, right? Another 12th standard student. Please come. Please come fast. Anybody? Let us not waste. Already we are late, right? And in between, please come here. I have my right hand, Shivakumar, who is our lab assistant. He helps me a lot, not only in keeping the lab ready, but also drive my car. So he is all in one. He knows what experiment I am going to make, a demo, what is required, what is not required, and if at all everything goes well, full credit should go to him, not to me. And this experiment, one more student is required. Let you please come. Come. You only come. Anybody can come. Boy or girl, whatever it is. You are? 9th. Okay. Nobody is ready. Come, please come. So many will be running to the platform once called. ಬೇಗ ಬರ್ಬೇಕು ಅವ್ರು ಭಾಳ ಲೇಟ್ ಆಗಿದೆ ಇವತ್ತು. ಬನ್ನಿ. I will request these friends to introduce.
My name is Anup. We are from Bagalkot district.
Bagalkot district. Which standard?
9th.
When did you come?
Morning.
Good.
My name is Nishal and I'm 12th standard.
Which school?
ICPU College.
Bangalore.
From Bangalore.
Please come. Well, today morning we got this cylinder filled with carbon dioxide. Right? I will get you all the theory little later. First, let us see the experiment demonstrated by these two friends. This cylinder is specially connected to what is called ice making apparatus. Ice making apparatus has one steel pipe which has got very, very narrow opening or narrow orifice and connected to 2 ebonite discs. Right? 2 ebonite discs are so purposefully used because they can sustain very, very low temperature. And what we are going to do, we are going to request these friends is, Shivu, your help me. We are covering this. Suppose we will open this first, see what is going to happen. Okay, right? Anything that you are going to see here? Is there anything collected or solid formed? No, right? So what these friends will do is, what is your plastic paper? First plastic. He will cover it. Means what is now open system, please know, what is now open system will be closed, right? By some simple insulating material. Okay. You will have little later work to tie. You take that bag also. Bag. Cover it. Bunny, new bunny. At the bottom also you should hold it. Madam? The system is closed system now, right? We have the standard definition of what is open system, what is closed system, what is adiabatic expansion, what is isothermal expansion. I am not going into the details of each and every definition. What was earlier open system is now converted into closed system, preferably with insulating material or warm material like silk or pure silk or pure wool, right? And now you come this way. Come this way. Come to the front. Come to the front. Yeah. Now, after a long time, we are using this cylinder because of COVID. I never had any such programs. For 2-3 years, the cylinder was kept totally empty. Only today morning we got it filled. and purposely we have brought a small cylinder because carrying bigger cylinder is extremely difficult. And like you see what is called LPG, liquefied petroleum gas, that is already liquefied. Here also you will have at the bottom liquid form of carbon dioxide. As you go from bottom to top, it would have been more of a gas and less of liquid, right? And if it is pakka airtight, right, if there is no leakage at all, let us see by opening the wall, is there anything collected or not, right? You had enough lunch, you have to open this wall, right? Sir, please note, there was nothing in the ice making apparatus, only we have converted the open system into a closed system, right? Now, Shivu will help. ಇವರೇ ಓಪನ್ ಮಾಡಲಿ. ಡ್ರೈ ಐಸ್ ಬಂದರೆ ಇವ್ರಿಗೆ ಚಪ್ಪಾಳೆ, ಇಬ್ಬರಿಗೂ, right? Come. You will collect it later if he is successful. You be there only in the frame. Come this side. ಎಲ್ಲ ಓಪನ್ ಮಾಡಿಬಿಡಿ because he has come all the way from Bagalkot. Now you can see whatever has been liquid from the cylinder is undergoing expansion. This is called adiabatic expansion. ಇಲ್ಲೇ leakage ಆಗ್ತದೆ, ಇಲ್ಲೇ ಕವರ್ ಮಾಡ್ತಾ ಇಲ್ಲಿ ನೋಡೋಣ ಇಲ್ಲಿ ಕೊಡ್ತೀನಿ. But it will be too cold, huh? You give it a gloves ittala Shivu. ಈ gloves ಬೇಡ. There is a leakage, but anyway, let us see. You be careful, huh? You are not that experienced, he is experienced. What's your name, you said? Anup. That's all.
Nishad Moran. Nishad Moran.
Okay. Nada. Madam? Yeah, madam. That is in large scale. Very, very large scale. At laboratory scale or at school or college level, I don't think anybody has demonstrated it. We have demonstrated this experiment over Doordarshan several times. You can see the theory behind. I will go through the slides. Let us wish them all the best that they will collect something here. Now you try your luck. He has tried his luck and he has experienced a lot of cold and low temperature, effect of low temperature. You are comfortable? Come here. They should be able to see. ಇಲ್ಲೂ ಇದೆ, right? ಕೈ ಮುಟ್ಟಬೇಡಿ. Don't hold it by bare hand. Which day is good for you? Today is very good day. Any day is good day for good work, right? Let us hope something would have been there, otherwise some standby is there, not to worry. don't touch my bare hand. Open. I will tell you, madam, everything. ಇಲ್ಲ ಬಂದಿಲ್ಲ. ಓಕೆ, ಎನಿವೆ ಓಪನ್ ಮಾಡಿ ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಇಲ್ಲೇ ಲೀಕ್ ಆಗೋಗಿದೆ. ಇರಲಿ, ತೋಡಿ ಡ್ರೈ ಐಸ್ ತೋಡಿ. She has been very little lucky because only so much is collected. We have not, like I said in the beginning, for almost 3 years, cylinder has never been used. But like I said, we have got standby, and while coming, we purchased about, please come, about 10 kg of dry ice. Many times rehearsal will be successful and main show will be flop. ಕೆಳಗೆ ತಗೊಳ್ಳಿ, ಕೆಳಗೆ ತಗೊಳ್ಳಿ. Now this is how we get cake, right? That will be opened and shown, and we require a special container, thermally insulated container, which can sustain about minus 100 degrees Celsius. We'll open this. Sir, ಬಿಸಿ ನೀರು ಬೇಕಾಗಿತ್ತು. Hot water. I told in the canteen. ಇಲ್ಲಿ ತೋರಿ, ಬ್ಲೇಡ್ ತೋರಿ, ಇಲ್ಲಿ ತೋರಿ, ಶೂ. ಗ್ಲೌಸ್ ಹಾಕೋ, ಗ್ಲೌಸ್. ನೀವು ಗ್ಲೌಸ್ ಹಾಕೊಂಬಿಡಿ, ಇವ್ರಿಗೂ wear that gloves. What did I tell you? We are not supposed to hold it by bare hand. Blood clots because it is at minus 77 degrees Celsius. ಸಾಕು, ತೆಗಿ, ಕೆಳಗಿಡಿ. ಅದನ್ನು ಓಪನ್ ಮಾಡಿಬಿಡಿ, ಕಂಪ್ಲೀಟ್ ಓಪನ್ ಮಾಡಿ, ಹಾಗೆ ಓಪನ್ ಮಾಡಿ ಟ್ರೈನಲ್ಲಿ ಇಟ್ಬಿಡಿ, ಟ್ರೈನಲ್ಲಿ ಶೂ. ಈಗ ಓಪನ್ ಮಾಡಿ. Yes. Now, I hope she can hold 10 kg. Can you sustain the 10 kg? ಎಲ್ಲನೂ ತೊಗೋಬೇಡಿ, ಎಲ್ಲ ತೊಗೋಬೇಡಿ, ಶಿವು ತೋರ್ಸೋಕ್ಕಾಗಲ್ಲ. ಬಾಕ್ಸಲ್ಲಿ ಹಾಕಿ, ಬಾಕ್ಸಲ್ಲಿ ಹಾಕಿ, ಬಾಕ್ಸ್ ತೊಗೊಳ್ಳಿ, ಬಾಕ್ಸ್ ಇಲ್ಲಿ ತೊಗೊಂಡು ಬನ್ನಿ. We'll show you, we'll bring it up to that last step, not to worry. ಅಷ್ಟು ಎತ್ತಕ್ಕಾಗಲ್ಲ ಶಿವು ಅವ್ರಿಗೆ, ಎತ್ಬೋದಾ? ಹಾಂ, ತೊಗೊಂಡೋಗಿ. Now why is it called dry ice? Please listen to me, right? And what is the difference between a regular ice and this dry ice? What are its applications? How the gaseous or liquefied form of carbon dioxide is converted into solid form of carbon dioxide will be shown and explained through this slides. But in between, she will simply take it, not to everybody. Everybody will be so curious to touch it and salute you also. Let it not happen, right? Let him first see. What is happening now? What is happening now? What is that process called? Question to him is question to everybody. Evaporation 1, somebody said sublimation. Who said? Teacher should not answer. it undergoes sublimation, it sublimes, your fingers will not be wetted, therefore it is called dry ice, right? Please take it to the last step. Simply show this way, right? Ask them not to touch. Slowly, let them see. Can you imagine whatever carbon dioxide is there in the air in the gaseous state is made to undergo within fraction of a second thousands and thousands times what is called Joule-Thomson effect, right? And I will explain through the slides also. At one stage, it not only becomes liquid but also converted into solid. It will be in the liquid state what we get here in the cylinder. Right? Yeah. Yeah, in this case. Well, what is this? Yes, please come. Thank you, both of you. Most of you must have used this spray, perfume, right? You must have observed whenever you spray this, what is it you feel? Not that fragrance, cool, right? That cooling effect is because liquid enters into a capillary tube, right? And when it comes out, it will not be in the liquid state, it is in the atomized state, gaseous state. That means liquid is converted into gas. Exactly same principle is used even in making of this cylinder, right? What is this Joule-Thomson effect? Joule-Thomson effect is the principle behind the air converted into liquid. Please listen to me. Air converted into liquid, where from we get nitrogen and oxygen separated, liquid oxygen as well as liquid nitrogen separated. And the exactly same principle is used even to make dry ice. When a gas migrates from a region of high pressure to a region of low pressure through a fine opening, due to the sudden expansion, there will be fall in the temperature, bringing about cooling effect. This itself is called JT effect, popularly known as JT effect. And how is it done? Look at the entire structure. What cylinder we have used, more of liquid of carbon dioxide at the bottom, and as you go up and up, it is in the gaseous state, right? When you open the wall, liquid carbon dioxide enters into the tube, and since this entire system is insulated, there is no exchange of matter as well as energy. There will be change in energy only when work is done by the system. And what is this system here? Carbon dioxide is going from liquid state to the gaseous state. Work is done by the system. The intermolecular distance increases. As intermolecular distance increases, work has to be done by the system at the expense of its own internal energy. Since there is loss in the internal energy, what was at room temperature is now at minus 77 degrees Celsius or minus 70 degrees Celsius, right? At minus 70 degrees Celsius, carbon dioxide cannot be either in the liquid state or in the gaseous state. It has to be in the solid state only. We should have collected, but because the equipment has not been used for a long time, there was so much of leakage of carbon dioxide. I shall see that it is rectified for the next attempt. Now, what for this dry ice is used? Several applications are there. One such application, right, is this was the picture that I could take while making dry ice only. This already you have seen. Let me not repeat, right? Triple point. At a particular point, all the three physical states will exist of any substance. That is called triple point. So carbon dioxide at minus 51 degrees Celsius exists in the gaseous state as well as liquid and the solid state. And below this temperature, it is more in the solid state and less in these two forms. And when we talk about the applications, let us see. Okay, sir, can we play that dry ice video? Mainly that is used in entertainment industry. Let us see whether we can play this or not. Yes. Can you have sound also, audio? I was fortunate to shoot this when Muhurta shooting was going on of this Kannada movie called Mahasadvi Hemareddy Mallama. And one day shooting that particular shot, they have used 6 tons of dry ice to create what is called heaven. And what is heaven you will see there first and then here on the platform. You just see how much of dry ice is used there. It was shot in Abbai Naidu studio, Bangalore. See, that is dry ice. He will introduce that into hot water. See the effect. You see. From morning 10 to 5 o'clock, I was there. I was permitted to shoot this for educational purpose. Otherwise, normally they will not allow. I came to know at the end of the day, 5 tons of dry ice was used. 5 tons. ಬಿಸಿ ಇರಬೇಕು. And though consumption is so much of dry ice in Bangalore city, especially for cinema industry, then event management, etc., it is not made here in Bangalore. It is manufactured in Chennai or in Goa. I don't know. ಬಿಸಿ ಇರ್ಬೇಕು ಸರ್. So Lord Shiva and Goddess Parvati are there in Kailash, in studio, and the heavenly scene is created there. And every day they have to handle kilograms, quintals. You could not even sustain the temperature here for 5 minutes, right? They have to be there right from morning till evening. ಬಿಸಿ ಇದ್ದಷ್ಟು ಚೆನ್ನಾಗಿ ಇಲ್ಲಿ Director was Renuka Sharma, who directed Kaviratna Kalidas and other noted films. Unfortunately, in the second wave of COVID, we lost him. You see, shooting is very, very boring to see, whereas you can enjoy cinema for few minutes, but number of people working behind, so much expenditure, all that, why producers at one stage become beggars is because of such expenditure only. Another half a minute is there, please tolerate it. For one dialogue of few seconds, so much expenditure, cut it, that's all. And I want to show at the end how loss will be there for lorry loads of dry ice will be kept for such sequences. That's all dry ice only. ಸ್ವಲ್ಪ Yeah, okay, that's good. Fine. Fine. Those containers are all filled with hot water. Then they put dry ice. What you get out in the form of clouds is moisture, and carbon dioxide is heavier than air. It sinks to the bottom. And if water is boiling, you will have a little amount of steam also. Yes, this is song sequence, and after this there was a horrible accident. What is it, sir? Yes, while I was coming from Belgaum by car, I could see one truck meeting with an accident, and I saw that people were so busy collecting. It was the cold storage lorry coming from Goa, and it was carrying dry ice. The cakes, 10 kg cake, each cake is 10 kg. You see the loss. It blocked the highway, and the police were not knowing whether it is any explosive or dry ice, and they were taken to task, right? Can I go to the PPT? Yes. Okay. Since you have seen the movie, no need. Yes. You see now the other applications. Certain medicines have to be, certain life-saving medicines have to be transported from one country to the other country, and they have to be preserved properly. To preserve such medicines, they cannot use regular ice. They have to use dry ice. Since we had collaborative research going on between our organization and Ehime University, Japan, we had collected the urine samples, hair sample, breast milk sample for some analysis, and we had to send the samples to Japan for special analysis, and we all stored them in dry ice up to Chennai, from Chennai to Japan by flight, again in the special container. See the application. Application is not only for entertainment field, but also in the field of medicine. And many times we see when somebody has reached his or her end of life, sometimes the final journey and funeral will not be there, taking place immediately. The body has to be preserved for nearest and dearest people to come and pay their last respect. For that, preservation has to be done properly. And if preserved with regular ice melts, becomes water, body starts undergoing decay at a faster rate. Instead, they have to use the dry ice. And person, this great footballer, right, who died while playing only in Bangalore, right, his body was transported to his native place after several days, and all that preservation was done in presence of the dry ice only. Most of the time we talk about drought, and we read on the paper that government is planning for cloud seeding, government is planning for the artificial rain. What is this artificial rain? Artificial rain is nothing but some silver compounds with dry ice sprayed like this, right? Why the cloud seeding and artificial rainfall is expensive is because the use of expensive chemicals, including dry ice. Dry ice is nowadays 80 rupees a kilogram for educational purpose, right? Otherwise, it is not less than 150 a kilogram, but not only buying is, but also preservation is difficult. you should have got special containers, use it in the limited time, etc., etc. Then we have this particular slide I shall skip. Right now, we'll have one more experiment. Can you have the lights, please? Right? You know that carbon dioxide is a non-supporter of combustion. Right? It will not allow the burning materials to continue burning. And for that, what we are going to do is, we'll have a jar, right? Please note that this gas jar is thoroughly washed, wiped and all that. It is pakka cleaned gas jar, right? And we'll have a jar with, and we have a candle. Let us see whether the carbon dioxide generated helps further combustion of candle or not, right? Off agata? Pakka? Guarantee? Yake? Does not support combustion. Carbon dioxide is a non-supporter of combustion. But are there metals or are there elements which continue to burn even in presence of carbon dioxide? Full open. Shall we try? Or you will try? Huh? Please come. Come faster. What you should do? What you should do? Come this side. I will help you, don't worry. What you should do? First, yourself. Come on.
My name is Tejas. I'm from Vishwavidya Peet School. Bye.
Very good. What you are going to demonstrate?
We are going to prove that carbon dioxide does not support combustion.
We'll see. Are you going to believe him or you want to see? Okay. Try your luck, man. Where you should introduce? Into this jar? In that jar. Very bad. What happened? Fire got up. Why? Carbon dioxide in the jar does not support combustion of fire. Okay. Let us wait. Yes, my question. Is there any element or substance that continues to burn even in presence of carbon dioxide? Magnesium. I got magnesium, right? And it was stored for a long time, and therefore with the help of sandpaper, yes, you should rub it with sandpaper. I have rubbed it already with sandpaper. He knows better than, right? And what we are going to do is, we'll burn this, and burning magnesium will be introduced into the same jar where already we have gaseous carbon dioxide. This I will not give you. I will only do. Okay? And let us see whether it continues to burn or not. And let us also see the products formed. Right? You be this side. Please come this side. Sometimes if glass cannot sustain that high temperature, it may be shattered to pieces. Light off ಮಾಡಿದ್ರೆ ಇನ್ನೂ ಚೆನ್ನಾಗಿ ಕಾಣುತ್ತೆ. ಇಲ್ಲ ಆನ್ ಮಾಡಿ burns with a dazzling light, right? So much should be enough. I will explain. Now, can we have the lights? Okay. Thank you. Go there. Now, gas jar was thoroughly washed and it was wiped, it was clean. Where from we got these black spots? Loudly, loudly. Whatever you say, right or wrong, be loud enough. So, yes, somebody? Chemical reaction between water. Tell me the products. Yes. You wanted to attempt, no? Yes. Now, please see, the temperature is so high of burning magnesium ribbon, it decomposes carbon dioxide into carbon and oxygen. That liberated oxygen helps further combustion of magnesium, not only with oxygen, but also with the nitrogen of the air. So what are the possible products that we get? Number one, decomposed carbon and oxygen. Decomposed carbon is deposited on the inner surface of the jar. It is found by analysis that it is nanocarbon. And what powder we have got collected here at the bottom, it is a mixture of magnesium oxide plus magnesium nitride, Mg3N2. Not only it reacts with oxygen of the air, but temperature is so high that it reacts even with the chemically inert nitrogen to become magnesium nitride. So, it has been rehearsed several times that burning magnesium continues to burn even when it is dipped in boiling water. I shall repeat, burning magnesium continues to burn when that burning magnesium is dipped into even boiling water, because the steam generated at the surface undergoes decomposition. Normally water is used as a fire extinguisher, but in this case the steam generated at the surface decomposes, producing hydrogen and oxygen. Oxygen liberated helps the further combustion of magnesium into magnesium oxide, and hydrogen is a self-burning gas. So you will have double dhamaka there, burning magnesium as well as hydrogen. And with that note, let us see whether we have got another experiment. That's about the, yes, I told you, sometimes the rehearsal will be pakka and the final experiment will be flop. Thinking that experiment may be flop, in my house experiment conducted has been photographed. Right? Now we'll try this, and to try this experiment I request these two friends to come this side. Let us try this. First see the experiment and then I shall explain why it happens. You also please come this side. Candle. No, I will direct this. This is filled with corn powder, maize corn, right? And it is so fine powder, you know that from starch ultimately we get glucose. And when it is sprayed, whatever is in the powder form again gets atomized. Each atom, each particle, fine particle, gets so much of oxygen available in the air that each particle gets lit up, gets fired up. And that's what we can see now. Let us try. Sometimes it may fail, sometimes it is dangerous also. Sometimes even candle may be put off. Let us see. let us focus on this. Corn powder, madam. Maize corn. If it is put in bulk, but if it is atomized, small particles, that will be the effect, madam. No, we have to repeat. Let us try. Otherwise, you have to appreciate this slide only. This we have tried several times. One last time, yes. No, sorry. Let us not waste time. Now, this is the effect. This has been caught while the experimenters demonstrated in one of the schools, and this I will explain it as, you must have studied what is called law of mass action. As concentration of the reactants increases, the rate of the reaction also increases. By spraying it, when the area gets expanded, what is called the nanoparticle, right? As surface area of the corn powder increases, each particle gets atmospheric oxygen for its continued burning, and sometimes if the bulk falls on the flame, it is put off. Like madam said, it is used as the fire extinguisher. It acts as both. It depends upon how the corn particles reach the flame of the candle, right? And let us see the experiment. This experiment can explain the whole of the chapter. You must have studied what is called electrolyte, non-electrolyte, right? Then how electrolytes are classified as strong electrolytes, weak electrolytes, and how to you can occupy your place, right? I have specially designed equipment, right? All these are made up of acrylic, purposely to avoid the use of fragile glass, number one. It also acts as electrical insulator, and we have got 4 bulbs. Each bulb is of 40 watt. There is no difference in the wattage of these bulbs. The first container is already filled with solid salt, common salt. The second one I am going to fill it with distilled water purchased from petrol bunk. I rely that it is pakka distilled water. Let us have distilled water, right? Then even third container I will have distilled water only. And the fourth one I shall fill it with, can you read what is this? Kerosene. Kerosene is any organic solvent you can take. Preferably I use kerosene because it is not as volatile as alcohol, as volatile as acetone, right? So this also is, you can take kerosene, benzene, toluene, anything you can take, right? And now what I shall ask Shivu is to, yeah. Now all of these are on only. 1, 2, 3, 4 connected in series. ಕೆಳಗಡೆ on ಇದೆಲ್ಲ 1. ಈಗ on ಮಾಡಿ. I am using AC current, not DC current, right? This is only for demo and only to understand electrolyte, non-electrolyte, how to classify weak electrolytes, what is degree of dissociation, etc., etc. Okay? No teacher should repeat this or reproduce this, because if teacher is fully involved in explanation, he or she, instead of using some insulating material to stir, etc., he or she may use fingers, will very dangerous. In most of the schools and colleges I have seen teachers and students using DC, that is fine, but the difference between AC and DC here, in case of this there is no electrolysis going on. Electrolysis does not take place, whereas in case of DC, the electrolysis taking place will not help you to classify all these materials as electrolyte, non-electrolyte and all that. Ella indicate on idea. Now please see, hack. No switching. The indicator lamp. ಆನ್ ಆಗಿದೆ, ರಿವರ್ಸ್ ಹಾಕಿದ ನೀನು ಒಂದು ಮೇಲ್ ಮಾಡಬೇಕು, ಆಫ್ ಮಾಡಿ ಹಾಕಿ. 0 is off, 1 is on. ಈಗ ಅಯ್ಯ ಸಾಲಿಡ್ ಸಾಲ್ಟ್. ಅಲ್ಲಿ ಆನ್ ಯಾವುದೋ ಇಂಡಿಕೇಟರ್ ಆನ್ ಇಲ್ಲ ಮೇಡಮ್. ಇಂಡಿಕೇಟರ್ ಲ್ಯಾಂಪ್ ಇಸ್ ಬರ್ನಿಂಗ್ ಆರ್ ನಾಟ್? ಅಲ್ಲಿ ನೋಡಿ ಸರ್, ಸ್ವಿಚ್ ಸ್ವಲ್ಪ ಪ್ಲೀಸ್. ಎಳಿಬೇಡಿ ಪ್ಲೀಸ್. ಬಂತಾ? ಓಕೆ. Now, yeah, unfortunately, distilled water is not 100% pakka distilled water. Bulb is glowing, but of course with the dim filament. Now others are all off, though current is flowing. What does it mean? A substance that conducts electricity either in its molten state or in the form of solution is called an electrolyte, but never in the solid state. Molten state at melting point or in the aqueous solution form due to the presence of ions. We have got solid salt, right? Does not have any free ions. Due to the absence of ions, it fails to conduct electricity, and therefore solid salt is a non-electrolyte. But when you come to the case of, I don't know, this is not washed properly, maybe this container is not washed properly, it doesn't matter, right? At least in the third container you can see distilled water again taken. I had second and third container having distilled water, fourth one kerosene. Okay, now what I will do is, for the third container I'll just squeeze little amount of lemon, right? And let us see. Electrodes, regular metal, steel rods. All the four are there, madam. All the four indicator lamps. Switched off. Is not on. I'll off my first. Is it 1 or 0? ಆನಲ್ಲಿ ಐತೆ ನೋಡಿ, ಎಲ್ಲ ಆನ್ ಇದೆ. ಡಸಂಟ್ ಮ್ಯಾಟರ್, ಹಾಕಿ ಆನ್ ಮಾಡಿ. It doesn't matter because we have other proofs also, not to worry. Now what I will do is, to the second container only, which contains what? distilled water, I am going to put little amount of glucose. Glucose is an organic molecule, C6H12O6. Let us see whether dissolution means ionization also. Fortunately, on its own it dissolves, right? And there is no increase in the intensity of the filament. Okay, means organic molecules such as glucose is dissolving but not ionizing, hence there is no increase in the intensity of the filament at all. And in the last container, let us try whether current is flowing or not, otherwise I will try with the first one only. Putting common salt, right? First one is there, that has solid salt. No, there is something problem with this. We'll try this only. This means common salt instantaneously or spontaneously dissolves and also ionizes, giving Na plus and Cl minus. Greater the number of ions, greater the amount of current flowing, and hence the intensity of the lamp is much higher than what it was earlier with only plain distilled water. Some disconnection must have been there, no problem, but at least you can understand the concept. And again I said, sometimes experiment during rehearsal will be pakka, and during final presentation it may be flop. Madam? Definitely. Why? Yeah, that will be too much. You will have 40 watt. No, please see that electrolyte definition I gave. Non-electrolyte is any substance that does not conduct electricity either in the solid state or in the molten form or in the aqueous solution is all referred to as non-electrolyte. Now, how the degree of dissociation depends. The degree of dissociation or degree of ionization is dependent on these factors. You must have been taught at 11th and 12th standards. Nature of the electrolyte, strong or weak electrolyte, right? Common salt is strong electrolyte, being pakka inorganic, and citric acid, when lemon was squeezed, being organic in nature, is a weak electrolyte. There should have been dim filament. Then it depends upon the nature of the solvent, right? When common salt, if added to this kerosene, you stir it for hours together or for years together, never it dissolves, because substance is inorganic in nature, substance is ionic in nature, but you have chosen non-polar solvent. That non-polar solvent is kerosene. Non-polar solvent does not have required dielectric constant to break the bond between Na plus and Cl minus. And when bonds are not broken, you don't have free Na plus, you don't have free Cl minus. Due to the absence of the oppositely charged ions, there cannot be conductance observed, and therefore depends upon the nature of the solvent. Then temperature. If the same solution containing water and salt is heated, the extent of ionization increases. As the extent of ionization increases, the conductance also increases, and filament should have burned, or it would have been much more intense. It depends upon a dilution and also the presence of other substances. And sometimes this, yes, I exactly gave the same experiment there. When lemon was squeezed, out of the 4 bulbs, only this bulb is burning and the filament is so dim. It shows that the extent of ionization of citric acid is quite low. Its alpha value, its degree of dissociation value is quite less. If degree of dissociation alpha value is equal to 1, means it is a strong electrolyte. Number of molecules dissolved is 100, and all those 100 molecules dissolved have undergone ionization, cent percent ionization. And in the second one, we have all this, we have already shown. And you see with the salt and the distilled water, the filament burning very brightly, instantaneously, right? And we have this experiment also. In fact, I said if instead of AC current you have passed DC current, what would have happened? Electrolysis would have taken place. Electrolysis is the oppositely charged ions will migrate towards the respective electrode, right? The cation takes one electron to become neutrally charged atom, anion loses an electron to become the neutral atom, and that's how this experiment is so interesting with several applications. You see there what has been done is, I shall go to this, right? We have taken a glass, you can take beaker or such electrolytic cell also. Biಸಿ ಇದೆ ನೋಡಿ ಇಲ್ಲಿ, ಬಿಸಿ. This has been a simple electrolytic cell where graphite electrodes are introduced. And before I go for this experiment, since we have enough dry ice, we can create this entire platform into heaven. Come, you come. Yes, you also come. You also come because you worked here. All right, come here. Let us go. With you, I will also come to heaven. When somebody is still alive, we have got chance to go to heaven. You know, very rare case. Come. Bani, bani, bani. ಹಾಕ ಅವ್ರಿಗೆ ಕುಡಿಬೇಕಂದ್ರೆ ಗ್ಲೌಸ್ ತೊಗೊಂಡು ಕೊಡಿ. ಕಮ್ ದಿಸ್ ಸೈಡ್, ಯು ಶುಡ್ ಬಿ ಇನ್ ದಿ ಫ್ರಂಟ್. ಯು ಕೊಡಿ, ಇವ್ರಿಗೊಂದು ಗ್ಲೌಸ್ ಕೊಡಿ. ಡಬ್ಬಲ್ ಹಾಕಿಸು, ಡಬ್ಬಲ್ ಆದರೆ ಚೆನ್ನಾಗಿ. ಎರಡರಲ್ಲಿ ತೊಗೊಳ್ಳಿ, ಎರಡು. ಒಂದು ಸ್ವಲ್ಪ ಬಿಸಿನೀರು ಬೇಕು, ಸ್ವಲ್ಪ ಬಿಸಿನೀರು ಬೇಕು, ಹಾಗೆ ಇಟ್ಟಿರಿ ಸ್ವಲ್ಪ. ಇನ್ನೂ ಹಾಕಿ, ಇನ್ನೂ ಹಾಕಿ, ಇನ್ನೂ ಹಾಕಿ. Yes. Yes. 1 or 2 pieces. Give chance to others also to go to heaven. Put it in the hot water. Don't worry. Haki ಏನಆಗಲ್ಲ. Dip it, man. Okay, leave it. Give it to him. You never said your name. Long back. Last year only. Good. Come. Go to heaven. Put it. Yes, one more. Because you said your name long back. Bigger one you take, man. You are so lucky. So much is there. I cannot take it home. Even if I pack it in the container, right? Yes. Rest is all yours. You are so lucky that you can. Light travels in a straight line. Right? Can you see light traveling in a straight line? See there. Yes. See, exhausting everything. Come. Stand there. Yes, heaven. That stuff, man. Come here. Move towards your friends and tell them that you are enjoying heaven when we are still alive. Tell them, man. Yes.
We are in heaven
With the special effect of
dry ice.
Put in
Hot water.
Yes. You also should say.
Hi guys, we are enjoying heaven when you're still alive with the effect of dry ice.
Clap for him. Madam, please come. You don't want to go to heaven. Come here.
We are in heaven, still alive by dry ice in hot water.
Okay, good. Thank you. Okay. That is all water vapor, since it is hot water, and carbon dioxide, right? This is what is called the special effect created in most of the entertainment events and cinema shooting also, right? So this I will take it because this will divert your attention. ಸಿವಿ ಎತ್ಕೊಂಡ್ಬಿಡಿ ಆ ಕಡೆ, ಇಲ್ಲಾಂದ್ರೆ ಅದನ್ನೇ ನೋಡ್ತಾರೆ, ಸ್ಲೈಡ್ ನೋಡೋದೇ ಇಲ್ಲ ಅವರು. Okay, please focus on this. If sodium chloride is electrolyzed, right? Yeah, I'll see. Battery, whose battery? I don't know. This is working. This is working. Okay. Now, sodium chloride electrolyzed. We have got, sir. Okay. Right. We have got hydrogen collected and chlorine collected, and the leftover is sodium hydroxide. Sodium hydroxide being alkaline in nature. To the sodium chloride solution, just before electrolysis is carried out, we have put a few drops of phenolphthalein. And phenolphthalein imparts pink color in presence of alkali, and this is so simple reaction. One great Nelson extended it to manufacture of sodium chloride, and that manufacture of sodium chloride, the entire cell itself is called Nelson cell. What was preparation earlier is now converted into production of caustic soda. It is so important, commercially so important product, that not only we collect sodium hydroxide, whose applications are several, we are going to list it out. We also collect chlorine as well as hydrogen. Chlorine and hydrogen are made to react with each other to produce hydrogen chloride. Hydrogen chloride is gas, is never acidic in nature. But hydrogen chloride, when dissolved in water, resulting aqueous solution is called hydrochloric acid. This difference we should be able to understand. And we get chlorine liberated, we get hydrogen liberated, we also get sodium hydroxide. And if this chlorine is utilized for some other purpose, how the applications can change. For that, you see sodium hydroxide has got plenty of applications. Without sodium hydroxide, no organic synthesis can be carried out. Without sodium hydroxide, no aluminum metal production is possible throughout the world. We have got everyday use soaps and detergents, make use of lot of sodium hydroxide. Then we have got water treatment, pulp and paper. No paper industry can function without the help of sodium hydroxide. And dyeing industry, textile industry, all these make use of lot of sodium hydroxide. And if sodium hydroxide is synthesized and converted into some other value added production, look at this. Sodium hydroxide, if made to react with chlorine, such a dilute solution is called sodium hypochlorite. Sodium hypochlorite is sold in the market as a mild bleaching agent, sold in the market with a different brand names. This is Rin. Rin is only brand name. Ala, right? If you read the content of this, mainly that is sodium hypochlorite. This is preferred only for white cloth, not for colored cloth. Earlier, it was sold in small containers under the title cups and collars, because most of us get our the clothes soiled mostly at the cups and collars, because we have got organic greasy material called dirt accumulated, and that sodium hydroxide present and chlorine present will remove all this dirt. And most interestingly, it is not the sodium hypochlorite used for the washing purpose. Look at its further value added production. Sodium hypochlorite, if made to react with ammonia, is converted into chloramine. NH3 is ammonia. Out of the 3 hydrogens, take out 1 hydrogen and replace it by chlorine. That is called chloramine. Chloramine further reacts with excess of ammonia to become NH2 bound to NH2 called hydrazine. Hydrogen is indirectly 2 nitrogens and 4 hydrogens. If this hydrogen and the other hydrogen are replaced by methyl groups, molecule is symmetric here, right? And if it is made unsymmetric by replacing 2 hydrogens by 2 methyl groups, right? This is unsymmetric dimethyl hydrazine. In short form it is called UDMH. UDMH is a liquid propellant. Without this, launching of rockets is highly impossible. You have got mobile van here outside, right? Brought from ISRO. Go and ask them where exactly UDMH is used. They will be in a position to explain better way than this. You see, common salt, when subjected for electrolysis using Nelson cell, not only caustic soda is produced, but also chlorine as well as hydrogen. Chlorine reacting with NaOH produces sodium hypochlorite. Sodium hypochlorite converted into hydrogen. Hydrogen converted into UDMH. UDMH launches the rocket to place further the rocket into the space in safe orbit. That means from salt to satellite, ಉಪ್ಪಿನಿಂದ ಉಪಗ್ರಹದವರೆಗೆ, for all that the natural materials available, we have to salute always. If at all we are enjoying mobile phone, if at all we are enjoying so many channels over television, all that credit should go to satellite. And that satellite launching requires different propellants, both liquid as well as solid propellant. And one of the liquid propellants is UDMH. Every day several tons of UDMH is produced by ISRO. And for all that, root cause is electrolysis of common salt. And for electrolysis we require DC current. No electrolysis, only electrolyte, non-electrolyte, weak and strong electrolyte, we require AC current, right? It is for academic purpose and this is for the practical and commercial purpose, right? And we have a few experiments, and now it is 4:30. I shall just make a demonstration of 2 or 3 simple experiments. This you know, periodic table very well. The elements are divided into 4 blocks, right? S block kept on the extreme left hand side, P block on the right hand side. In between nicely sandwiched elements are called D block elements because their electrons, as the electrons increase with the increase in the atomic number, added electron enter into the inner D subshell, keeping the outer S subshell configuration almost constant. And at the bottom of the periodic table we have got 2 sets of 14 elements each. First set is called the lanthanide elements and the second set is called the actinide elements. And amongst these are very, very special. D block elements are very, very special. They have got magical power. What is this magical power? Let me get you one or line theory behind. You see there, such properties associated with the D block elements are never exhibited by S, P and F block elements. Why we have to study D block elements? Why are they so special? They show variable oxidation number. S and P block elements never show variable oxidation number, right? They form colored compounds, right? They show paramagnetism, good conductors of heat and electricity, right? And act as catalyst for various reactions, form large number of complex or coordination compounds. Then we have got are sonoric in nature. When metals fall, you will have that melodious sound, that is sonoric in nature. Then we also got the metals with very, very high melting point and high density. The very unique feature of D block elements is they act as electron donors as well as electron acceptors. S block elements, they are only electron donors. Therefore, they are called electropositive elements. P block elements are only electron acceptors. Therefore, these are non-metals, electronegative elements. But in between, we have got D block elements which play double role depending upon the other ligand, other incoming group or atom or molecule, right? They act as both electron donors as well as electron acceptors, and therefore generally D block elements are called both Lewis acids as well as Lewis bases, right? Electron rich compounds are called Lewis bases, electron poor compounds are called Lewis acids. Few such properties I'll make a demo And one such interesting property is KMnO4, right? You know that potassium permanganate is purple in color or pink in color, right? When very, very dilute solution of KMnO4 made slightly alkaline is simply filtered through an ordinary filter paper, pink color gets converted into green color, first green color, then becomes yellow, and in the end it becomes brown also. Why it happens? It is because, can anybody guess why it happens? Simple filtration with ordinary filter paper. You need not have to buy even expensive Wackman filter paper. Even this, I have not brought the solution, caustic soda is not there, but at least slide is there. Simply filter, dilute, very, very dilute. I shall stress this, very, very dilute alkaline KMnO4 through filter paper. The filtrate that you get will not be pink, will not be purple, that will be green first, then becomes yellow, and finally becomes brown. Can anybody guess why it happens? Few seconds, let us be fast. Why color change takes place when simple filtration is carried out? You can attempt even wrong answer. At least you should be bold enough to answer. Chromatography, no madam, sorry. Can anybody try? He has tried. He went to heaven and came back also. Huh? So lucky people. All the three. Enjoying science itself is heaven. Right? What more you want? Now please see. Let us first see the next slide and then I shall explain. Right? See there. Mn in KMnO4, when you calculate oxidation number, it is +7. As oxidation number changes, color changes. I shall repeat, as oxidation number of D block element changes, color also changes. So Mn in KMnO4 has got highest oxidation number of +7, and that +7 Mn, when it is filtered through ordinary filter paper, becoming first green and then finally becoming brown, is because there will be reduction in the oxidation number. +7 becomes a +6. Green color is due to +6 oxidation number. Then it becomes +4 yellow, and finally it becomes +2, that is Mn +2. But who is reducing this oxidation number? Are we playing magic? No. Paper, right? What is there hidden in paper? Wonderful. Tell it loudly. Cellulose. Paper is a polysaccharide called cellulose. All sugars are very good reducing agents. You should remember. Right? All sugars are good reducing agents. And paper is cellulose. Cellulose is polysaccharide. It's a good and very, very steady reducing agent. It will not reduce at once. Step by step it helps Mn to go from +7 to +6, +6 to +4, and then +2. And all this requires the change in oxidation number, magical power, that's what I said, magical power of D block element, good reducing agent, powerful reducing agent, and there should be intermediate reducing agent. And if this experiment is carried out with a regular newspaper, reaction will be still wonderful, because newspaper is full of political news. They reduce you, including me, to any extent. No, madam, I should have shown it. I just asked whether funnel and other things. Funnel is there, filter paper is there. We forgot to bring KMnO4 and caustic soda. It happens sometimes, and therefore, whenever I rehearse, I take the pictures at home. Same container, and all this takes place in about 5 to 6 minutes, madam. In 5 to 6 minutes, you can see the beautiful purple color KMnO4 ultimately converted into Mn plus 2. Yeah. Huh. Brown. Hmm. Huh. Yeah. Yeah, but yeah, that's very good question, madam. Wonderful question. Though it is not in contact with the reducing agent, though it is not in contact with the say filter paper, it is still a very good question. First time somebody asked this, right? Therefore, senior people like you should be there to make us learn more. It happens even in the absence of reducing agent. Sir, technicians disappeared. This happens even in Doordarshan. They used to keep 3-4 cameras on and they used to go to canteen. Now without anyway, until they come, this you have seen. Without slide also I can show you one very interesting experiment. I got one cylinder, right? Not glass, since it is fragile in nature. I have brought it with the acrylic made, and there is, what is this, man? Can you read it? You come. He is sleeping. Fortunately, he is not snoring. Otherwise, your sleep would have been disturbed. Read, man. Phenolphthalein solution. Phenolphthalein is a typical indicator, acid-base indicator. No color in acidic medium and a pink color in. Okay. So I have got water, and to this I shall put a few drops of indicator. Sivu ಸ್ವಲ್ಪ ಇದರಿಂದ ತೆಗಿ. One drop, one whole ಮಾಡಬೇಡಿ ಸರ್. ಆಯ್ತಾ? Okay? So much is enough? Enough? Okay. That is indicator, madam. I say, this is water, plain water, I said. Right? Then I shall put little amount of kerosene. Observe the reaction. I will have several questions to ask. One who gives complete answer for having seen the experiment and answered my question, he or she will be given suitable award at the end of my presentation. So water we had plus few drops of phenolphthalein and then kerosene. This has not been labeled while coming only from the college he brought. This is sodium. Sodium metal preserved in kerosene. All first group metals being very reactive in nature have to be preserved in kerosene, right? Is there any element that is kept in water? Is there any element in the period? Don't look into the Google and all that with your mobile. Any element that is preserved in water. Gallium. It is phosphorus, white phosphorus. White phosphorus is quite happy in water. These alkali metals are quite happy in kerosene. If you just reverse what would not and what should not happen will definitely happen. Right? So I shall take a piece of this. One piece ಬಂತು ಸರ್ ಓಕೆ ಇದರಿಂದ ಚುಚ್ಚು ಇನ್ನೊಂದು ಇತ್ತಲ್ಲ ಇಲ್ಲ 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 spoon sometimes if it is wet, you know, even if moisture is there, that is dangerous. ಇದರಿಂದ ತೋರಿಸು ಚುಚ್ಚು ಚುಚ್ಚ್ರಿ ಚೆನ್ನಾಗಿ ಚುಚ್ಚ್ರಿ ಚುಚ್ತದೆ ಅಲ್ಲ ಈ ಕಟ್ ಮಾಡಿ a bigger piece will be cut into pieces. Please note, alkali metals are very soft, silvery soft metal, which can be cut even using a blunt knife. That softness is because of loosely packed body-centered cubic structure. All hard metals with heavy structure or high melting point, they have got what is called FCC, face-centered structure. And he is cutting that into smaller piece. One chip, one there, chip piece after sir. So now what we are doing is, we have taken sodium metal, cut into several pieces. We are folding it between the folds of, pressing it between the folds of filter paper to take away one the air piece. All that kerosene will be taken out, and I shall just drop keep watching and tell me what is going to happen there. ಹಾಕಿಬಿಡಿ ಯಾಕಂದ್ರೆ ಇವ್ರು ಮಲ್ಕೊಂಡ್ಬಿಡ್ತಾರೆ ನೋಡದೆ ಹೋದ್ರೆ. You have to come and explain what is happening. Come and see what is happening first. Come and close observation. Come this side. What is happening to sodium?
So sodium is boiling here.
No, boiling, okay. Then, it is his language. Okay. Then,
the color of the sodium is getting dissolved.
Okay. Anybody from the last bench? Those who are not seen, one of you can come see and then explain to your friends, because it's so far off, you may not be able to see what is happening there. Somebody can come. Yeah, you already come, man. Somebody who inflated the balloon? No? That is there. What is very important is, sodium, if put in water, there will be vigorous reaction. Number one, hydrogen liberated may catch fire. Very risky to carry out that experiment. And we have got kerosene at the top with a density of 0.8 gram per cc. And sodium has got the density of almost the same as that of water. It is 1. So when sodium is put into water, it tries to sink to the bottom, but the moment it comes at that demarcation level of water, it reacts with water to liberate hydrogen. That's what he said. There is what is boiling. It is not boiling. Hydrogen is liberated. It loses little weight, becomes less dense, and again floats to the surface. But the density is again, once that hydrogen liberated is diffused into the air, it tries to come to the bottom, right? The pink color, like Madam said, is due to the formation of NaOH, hydrogen liberated. This is the safe way that a teacher can demonstrate the property of sodium metal. Don't put sodium metal in water to show that it is highly reactive in nature, it is capable of releasing hydrogen and all that. Sometimes during demo only, fire may catch, teacher and nearby students may be put to risk. That should not be done. And this is what I thought very, very safe reaction. So it is not boiling, it is hydrogen gas liberated. So we call it as dancing sodium, right? Okay, thank you. Now we have another simple experiment with the leftover dry ice. Okay, for that dry ice leftover, I have got a container, right, filled with water, and to this water I am putting a few drops of universal indicator. Universal indicator is unlike the phenolphthalein, unlike methyl orange, where only two colors are shown depending upon the pH due to structural changes. But universal indicator can show 14 different colors for 14 different pH values, right? So what I will do here is I shall put a few drops of few drops of, what is the color? Green. What type of green? Kaddi kaddi. Okay, so I shall request Sivu to put leftover dry ice. 1 second, 1 second. Not only temperature. Temperature is room temperature only, no problem. Hot. Is there any change? Yellow, it becomes yellow. Carbon dioxide, yes, carbon dioxide. Now, what is the color change due to? You should raise your hand and tell me. Come this side. Come to the platform. Be careful. Camera is there. Only he has to answer. What was the earlier color? Green. Now? Orange. Why? What happened? Carbon dioxide. When dry ice is put, it gets dissolved, and due to the dissolved carbon dioxide, what happens to the liquid? What is your name? Harshvardhan. Great name. Okay. It is becoming acidic. Carbon dioxide dissolves in water to become carbonic acid. H2O plus CO2 will get you H2CO3, that is carbonic acid. And earlier water was neutral, chemically neutral. Now it is slowly becoming acidic in nature. And due to the acid, you look at the pH, right? Orange means what? Earlier it was green, neutral pH 7. Now it is becoming orange. pH becomes 5, and if you add little more, it may go down to 4 also. And as the pH decreases, right, it becomes more and more acidic in nature, right? You're going to piece kottibudi tinli. Tinboda? Tinbardu. Right? Never you should attempt even handling dry ice by bare hand. You can do anything with the regular ice, but not with the dry ice. Okay. Harshvardhan, thank you. Go to your place. Be careful, camera is there. Because like you, so many people outside this auditorium also observing, right? Yeah, madam. That also changes. And that's how aerated water circulates. These these soft drinks is all aerated water only, right? Then we have this experiment actually performed in our lab with microwave oven. As oxidation number changes, color changes, vanadium pentoxide V2O5 is treated with hydrochloric acid and tin pieces. Hydrochloric acid and tin pieces will liberate hydrogen. Liberated hydrogen will reduce vanadium from +5 state to +2 state. What normally the entire change takes place with the regular burner for 3 hours, with the microwave oven it was completed in just 2 minutes, right? And photographs have been taken. You see +5 is brown in color, whereas +2 you can see all this, right? +2 is blue in color. Another just like KMNO4 we had. KMNO4 had pink color, yellow color, then green color, ultimately brown color. You can see at least 4 distinct colors as vanadium V, right, reduces from +5 to +2 state. And this I shall catalyst. You know what is catalyst, right? A substance that that changes the rate of the reaction without itself undergoing any permanent chemical change, and that can be recovered at the end of the reaction, both in terms of quality and quantity, is called a catalyst. That change may be either in the positive direction or in the negative direction. Depending upon whether it is in the positive direction or in the negative direction, the catalysts are popularly known as positive catalyst and negative catalyst. We have all these examples, and at least 2 such demos I am going to make, and for that remaining these auto catalyst, biocatalyst I am not going to explain in detail. The slight difference between catalyst and catalysis is study of a catalyzed reaction is known as catalysis, right? Then we have this great man who introduced the concept of catalyst for the first time, and most of the D block elements act as catalysts, and few of them are very frequently used. This is a typical reaction, right? Rochelle salt you must have heard, or it is otherwise known as sodium potassium tartarate. Without the use of this, no Benedict's reagent is manufactured. Benedict's reagent available in any pharmacy is used to check urine sugar, not blood sugar, right? And there are plenty of such applications, and the reaction is so beautifully conducted. These are all the pictures that I have taken during rehearsal, right? Rochelle salt can be oxidized to carbon dioxide and other products with a powerful hydrogen peroxide as the oxidizing agent. But unfortunately, only with hydrogen peroxide, even at 70 degrees Celsius, it never decomposes, giving carbon dioxide and water. But if you can add only few drops of cobalt chloride, COCl2, reaction not only accelerates, but cobalt +2 becomes an intermediate compound called cobalt +3. In fact, that cobalt +3 accelerates the rate of oxidation of Rochelle salt into carbon dioxide and water. And what is observed very interestingly is the final solution is regenerated here. What was added is regenerated, means cobalt 2 plus added as catalyst is regenerated at the end of the reaction, means catalyst used initially is recovered at the end of the reaction in terms of quality and quantity, but only the intermediate cobalt 3 plus provides an alternate path of lower activation energy for the reactants to easily go to the products. In simple words, catalyst helps the reactants. Don't go to Himalayan mountains. I am here to reduce the height of the Himalayan mountain into Nandi Betta. You can easily cross over. That means the catalyst provides an alternate path. To whom? To the reactant, so that easily they can pass over to the reactant. But the beauty of the catalyst is what is used initially is recovered at the end of the reaction in terms of quality as well as in terms of quantity. And we have one very simple experiment, right? This I am going to demonstrate. You can see with your own eyes. amongst all the D block elements, platinum is known as king of catalysts. And to start with my presentation, I said ammonia oxidized to nitric oxide oxidized to nitrogen dioxide, then nitrogen dioxide when dissolved in water, not only nitric acid is produced but also nitric oxide regenerated. Regenerated nitric oxide can be reused several times. Amongst these three equations, the first equation is called the key reaction because ultimate yield of nitric acid depends upon the yield of nitric oxide. Interestingly, the first reaction, not only nitric oxide and water are produced, along with that 900 kilojoules of heat energy is liberated. Therefore, we say to the students that it is exothermic in nature. But some students in the back benches will ask, sir, it is only in the equation. Can we see whether heat is liberated or not? Yes, we can see here. What we have done is, we have got a conical flask, right, empty only, and we have got ammonia. It is liquid ammonia, not liquor ammonia. Please understand this difference between liquor ammonia and liquid ammonia is ammonia directly converted into liquid, ammonia gas converted into liquid, whereas liquor ammonia is ammonia gas dissolved in water, right? And ammonia has got pungent smell, right? And if the reactant is quite fresh, result will be quite fresh. You should be very careful in opening this bottle. Many times it is so dangerous if you are holding this, and if you are opening this way, you will have to buy dark glass and a stick used by visually impaired people. It has happened in our lab. 5-liter bottle. One newly appointed teacher asked one attender, please open the bottle of ammonia, dilute it. He was not trained. Both of them were elbowed only, right? He opened, and I am very sorry to say that attender was treated for 6 months in one highly specialized eye hospital, right? One has to be very careful. Bottle should be first kept immersed in cold water. Look at this great man who had gone to heaven, right? And open the stopper, and you should wait for some time. Okay? Then you can use it. Hope you will take this very seriously, those who are teachers here, right? Then I shall take so much should be enough. It should not be completely filled. There should be air. There should be air means there should be oxygen of the air. Okay? Paper should be there. Yeah. But shall we close? Close. Well, platinum wire, most of you must have seen or used in the lab, right? From a distance you may not be able to see. It is a simple glass rod to which thin platinum wire is sealed. Can you see, sir? You can touch and feel. Yes, last man. Very expensive, therefore I have brought very, very thin wire. Therefore I showed it to you, otherwise you would have plucked it. Because he knows the preciousness of the platinum. Because he had gone to heaven, you know. One more. Now with the lights off, a little later we'll see. Madam, you should appreciate those people, right? They have spent their lifetime They must have tried several several catalysts and then come to this conclusion. And what is done here is with a thin platinum wire, but the catalyst used is a huge disc of several meters of diameter. Ammonia and oxygen are made to come in contact with the surface of the catalyst. Oxidation takes place. Only initial heating is enough. So what I will do is, I will make it red hot, right? This red hot platinum wire I am not going to dip. Please note, I am not dipping it. I am just holding it just above the surface of ammonia. Ammonia gas is there. Oxygen of the air is also there. And let us see. If ammonia is fresh, then results will be very good. Let us try. I have tried this. For nearly 1 hour it remains red hot. Where from heat is supplied to that platinum wire? It is because of the reaction between ammonia and oxygen of the air in the empty portion of the flask. Right? And can you not believe that great man saying first reaction is exothermic in nature? Right? I have tried this several times. See, and as you go to the rim, you feel that it is off, but come down. So reaction or simple oxidation of ammonia with oxygen of the air to nitric oxide is exothermic in nature. No color. Nitrogen dioxide has color. NO2 is colored. You want to try? But madam? Madam, that was nitrous oxide. N2O, laughing gas. Earlier it was used in dentistry as local anesthetic. But people started more laughing even in the dental cleaning. Therefore, they have now stopped. Instead of showing the teeth to the dentist, they started laughing. That is banned now. If slight excess is fed, person becomes unconscious. All right? No problem? Harshvardhan? Very clear. And what is not clear, madam? Nitrous oxide is not there. NO and NO and water are the nitric. For that, chemical test has to be done. Unfortunately, it is colorless. We cannot identify. But if that NO is again brought in contact with excess of oxygen, it becomes NO2. But we are so confined place there, right? There should be too much of NO reacting with too much of oxygen. See, this I have tried. Until all that ammonia is completely oxidized, platinum wire remains red hot. Right? Brown, reddish brown. Yeah. So that is about exothermic reaction. Catalyst, one of the unique property of D block elements. Right? Then this also I will show you within a minute. This will be over within a minute. We have got copper wire. Now you can have even the lights on. Copper wire. Usually alcohols are oxidized to corresponding carboxylic acid even in the absence of catalyst. Alcohols are oxidized to respective acids. For example, ethanol is oxidized to acetic acid. Methanol is oxidized even in the absence of acetic acid. But acetone, those who are in 11th and 12th standard, they may be knowing CH3COCH3 is a typical ketone, right? It is dimethyl ketone. Ketones are not easily oxidized to the corresponding acids. For the ketones to be oxidized, there should be presence of catalyst, number one. More than that, ketones are so oxidized, the corresponding carboxylic acid produced will have one carbon atom less than the parent ketone, right? So if parent ketone CH3, COCH3 has got 3 carbon atoms, the product that we get is acetic acid. And what I am doing now is, I shall take very small amount of acetone. Somebody can read, right? Is it acetone? Okay. So I have copper wire, right? And this oxidation of ketones or acetone is a typical simultaneous endothermic and exothermic reaction. But you will see both. You will see both. First, copper takes oxygen of the air to become copper oxide, and that oxygen taken by copper will be given to acetone. Means catalyst will first sacrifice. I am there to help you, don't worry. I will get you an alternate path to reach the products at a faster rate, right? It should not be again dipped, right? It should be on the surface. Okay. What I will do is, I shall heat the copper wire. That's LPG lamp only, madam, imported from US, is nearly 5,000 rupees. But portable, and we have got gas also that can be filled. Otherwise, I used to carry 1 kilogram LPG cylinder, burner, etc. It is risky also to. So red hot copper wire will be placed here. Off my light, off my. This also I have tried several times. It remains red hot at least for 1 or 2 hours until all that acetone is completely oxidized to acetic acid. You see, first it blinks, means initial stage is endothermic in nature. Oxidation of copper to copper oxide is endothermic, and further oxidation of acetone, acetone to acetic acid is exothermic in nature, right? And acetone is the molecule with 3 carbon atoms, acetic acid is molecule with 2 carbon atoms. It is in the form of paper. It is in the form of paper only, and this you can see the equation, right? Same picture, right? Exactly same, right? Acetone molecule I given, arrow mark slightly changed, CH3 COCH3 plus oxygen of the air becoming CH3 COH, only 2 carbon atoms, here 3 carbon atoms, and it appears so simple reaction on the board, but it is a typical simultaneous endothermic as well as exothermic reaction, right? And yeah, it is there, madam, it is there, I'll get it. See there, all these equations. It is not single step reaction, so many steps are involved, right? Endothermic, then first one is endothermic, second one is exothermic. Typical, I have very rarely come across such reactions. And well, we have the same role of catalyst in providing an alternate path, all that I have explained, and this I shall only explain to copper sulfate. If you can put aluminum foil or iron, there will be what is called single displacement reaction. Iron displaces copper ions from copper sulfate solution. Iron does not replace copper atoms. Only ions will be displaced and that will be deposited onto aluminum. Well, this I already explained. We have got one last very interesting demo. Those who inflated the balloons, please come. All the three. Hmm. 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 Okay. Hmm. Pure? Okay. Huh. Correct. Huh. Hmm. Yeah. Hmm. Madam, for that, I have one, before I go to the interesting explanation, interesting experiment, for your question, there is one simple experiment. ಬಿಸಿ ಇದೆ ಇನ್ನೂ ನೀರು ನೋಡು ಇಲ್ಲ ಸ್ವಲ್ಪ ಬಿಸಿ ಬೇಕಾಗಿತ್ತು ಸ್ವಲ್ಪ ಒಂದೇ ಒಂದಿದೆ ಮೇಡಮ್ ಹಾಂ ಒಂದು ಗ್ಲಾಸ್ ಸಾಕು ಮೋಸ್ಟ್ ಆಫ್ ಯು ಮಸ್ಟ್ ಹ್ಯಾವ್ got this magic mug. Have you seen? Pardon? Gifted me. How many are there? 4. You give me. You return only one. Rest all give it to me. Next time. Not now. Where is your address? Get me your address. I'll send somebody. Magic mug. Not regular mug. What happened? Why? Yeah, now you have got 4 mugs, you know. At least once you have tried why it happens like this. Right? If I can get you detailed answer, how many you can return to me? Now let us see. See the details also. Light on Madisiu. Yeah, good. Why is it called magic mug? He better explained. When you pour hot water, image appears. When you can pour out that hot water, image disappears. That is all for that person who is selling you, who is gifting you. But as a student of science, you should know what is happening. That we are going to see. ಇದನ್ನು ಹಾಕು ಭಾಳ This hot water is not good. Not at all hot. ಇದು ಬಿಸಿ ಬೇಕಾಗಿತ್ತು ಸರ್ ಮಿನಿಮಮ್ 60 degrees. ಇದನ್ನೇ ಫಿಲ್ ಮಾಡ್ತಾರೆ ಅವ್ರು ನೋಡ್ಬೇಕಲ್ಲ ಸುಳ್ಳು ನಾನೆಲ್ಲ ಮಾಡೋದೆಲ್ಲ ಬೋಗಸ್ ಅಂತಾರೆ. ಹಿ ಈಸ್ ವೆರಿ ಕ್ಲೆವರ್. ಹಿ ಹ್ಯಾಸ್ ಆಲ್ರೆಡಿ ಗಾಟ್ 4 mugs. Minimum 60 degrees is required, or else we'll show that clipping, sir. ಅಲ್ಲ ಕ್ಲಿಪ್ಪಿಂಗ್ ತೋರಿಸ್ಬಿಡಿ. ಮ್ಯಾಜಿಕ್ ಕಪ್ ಅಂತಿದೆ ನೋಡಿ, ಮ್ಯಾಜಿಕ್ ಕಪ್. See, I said no, rehearsal will be successful, final experiment will be flop. Claps means you should stop. ಇನ್ನೊಂದು ಪ್ಲೇ ಮಾಡಿ ಸರ್, ಪ್ಲೇ ಮಾಡಿ. ಸುಮಾರು ಜನ ಕ್ಲಾಪ್ಸ್ ಮಾಡಿದ್ರೆ ಬರೀ. ಸಿ ಹಾಟ್ ವಾಟರ್ ಪುಟ್. And what is appearing there? Word form of periodic table. Mendeleev's periodic table. Without periodic table, no light, madam. And when you pour out hot water, yes. Sir, let us go to PPT. Last few slides, 2 or 3 slides. Now, to explain to this, right, this also I will show you. You should know variety of indicators, and you should also know the difference between paint and a dye. Can anybody tell me the difference between paint and a dye? Dye. D-Y-E, not D-I-E. Yeah, dye is hair for, good for whose hair? I never dyed. It depends on the skin, it has side effects, so many allergic problems will be there. And better to show that you are respecting your age also. Why dye? Why dye? When he calls, let us go. Why dye every day or every week? Paints are inorganic in nature, dyes are organic in nature. You should never forget this. Paints Italian dyes show different colors due to difference in the pH, due to difference in the structures. Likewise, we have got fluorescent dyes, we have got what is now known as a leuco dyes, L-E-U-C-O dyes. What dye is used in the magic mug is leuco dye. And leuco dyes are so interesting. I have given you this phenolphthalein. Phenolphthalein is colorless in the acidic medium. This you could show, right? Shows pink color in basic medium because change in the structure takes place when pH changes. This type of structure of benzene ring is called a benzoate structure. And when it changes its pH from neutral or acidic to alkaline, ring opens and this is called phenolite structure. Due to change in structure, change in color takes place. And that change in structure is due to change in pH. Likewise, we have got certain dyes used in magic mug. These are all called thermochromic inks or thermochromic dyes, right? Which are reversibly temperature sensitive. Each word is very important. Which are reversibly temperature sensitive dyes. Ring may be closed, ring may be opened of the leuco dyes depending upon whether it is at a low temperature or at high temperature. You see one such leuco dye used, right? When exposed to UV light or heat, ring opens. What was like this will be like this. Can you see? Ring closed here, whereas ring opened. Due to this, color changes will be there. There will be 3 basic colors or 4 basic colors whenever color print has to be made either on the paper or on any material. We say CMYK in printing language. CMYK is cyan. Cyan is blue. M is magenta, right? Y is yellow. K stands for black. The combination of these 4 colors in right proportion at right angle, that is very important. At right angle. Right means not 90 degrees. At a particular angle in printing language, right, will produce one final color picture. I should have brought this. Unfortunately, I could not trace my word pictures. I got all the 4 colors separation. And there are, magenta should be superimposed, perfect superimposed at a particular angle with yellow color, with particular angle of cyan color. Right? Only then you will get the pakka color picture. Otherwise, many times in the newspaper you must have seen, madam, nose will be split, ear will be split. Splitting is because that particular color is not superimposed or exactly imposed at particular angle. That in printing language is called registration. All the 4 colors should be properly registered. And among so many people working in printing press, person who is expert in registering is paid highest. He is expert in registering the colors. Once he certifies, he will say run lakhs and lakhs of copies. Registration itself takes 2 to 3 hours. And then final printing of lakhs of copies must be completed in just 1 or 2 hours. And these are all due to dyes. And what question you asked, depending on the color, right? You can just suitably choose the dyes. What color you want, suitably you will have to choose the dyes, right? And I shall go to this last but one. You must have seen this. Shivu. Okay. I have a small glass bottle, last but one, very interesting, right? I have got chlorophyll extract, not cough syrup, right? I shall pour it here. What is the color? Color should be green only, as it is chlorophyll, okay? When exposed to this light, no appreciable change is there, right? With the lights off, you will see the magic, not in the mug, right? Please observe what is happening. Yeah, this is UV light. What is the color? Pink or purple, whatever it is, right? Off, right? It is green again, right? You can see? Simple effect of violet color. You have what is the phenomenon taking place. See there, chlorophyll extract, when exposed to UV light, it becomes red or pink or purple, whatever you say, right? Why this happens? It is because whenever I shall come to that particular slide, no. Before this, yes. Whenever any substance is exposed to light, depending upon whether it is opaque or transparent, right? These four things have to happen. Light may be scattered, light may be transmitted, light may be reflected and refracted. This absorbed light may be temporarily there and immediately it must have been re-emitted. What is absorbed is high energy wavelength. High energy wavelength is UV, right? What is re-emitted is low wavelength, means less energy. You have that equation. C over lambda is frequency, nu, E equal to h nu. H is Planck's constant. And if absorption and re-emission takes place without any time gap, that process is called fluorescence. And if there is lot of time gap between absorption and the re-emission of the energy, that is called phosphorescence. And this phosphorescence most of the time is observed in graveyards. In graveyards, here and there may be some bone pieces, and that bone piece may have lot of phosphorus content, right? During daylight, the sunlight is absorbed, high energy is absorbed, that will be stored and that will be re-emitted in the night time. If it is particularly new moon day, Amavasya, total darkness, in the graveyard, glow will be there. Harshavardhana will talk to this man, you had gone to heaven, now we are in the hell, we are seeing devil, we are seeing ghost in the graveyard, right? It is simple chemical phenomenon. Light absorbed during daytime is re-emitted in the night time. so much time gap, that is called phosphorescence. But the moment we expose this chlorophyll extract, instantaneously there was re-emission of light of lower wavelength. Usually such phenomenon where there is no time absorption of energy and its re-emission is called the fluorescence. And you see how fluorescence has occurred. Simple reaction, very simple reaction, but can explain lot of theory behind. You have got all these simple definitions. Pass through oil. Which oil? Okay. Huh. I have not seen. Yeah, okay. Right. And you see difference between fluorescence and phosphorescence. Then we have got, I said, absorption of high frequency and re-emission of low frequency or higher wavelength, red in nature. Then we have last experiment. Those whom I invited, they disappeared, as though I am calling them for unique war. You see, it is still remaining a red dot. Okay, and what I will do is, it has become so hot, you cannot hold this. They have come prepared. Come on, those who inflated the balloons again went back. Good. I will only call this gentleman. You come man. You should be fortunate to come over here. Yes. Another man went out. They are taking. Yes. Now I will help and she will help. Okay. So we have thermocol container, right? Then last experiment, right? Then balloon kodi first. Are you hungry? Are you angry? Anyway, eat this. Eat. I will also eat, man. I will also eat along with you. There is an experiment. Give one to him. You should also come. There is a purpose of eating this, man. Come here. Come, man. Come. Eat this. You are the now or the thinner. Because we have shared the dais. Right? One balloon. Okay. We'll pour liquid nitrogen and then we'll place these bananas also. Anybody? I'll keep 1 or 2 bananas here. That's the purpose. Stand here. Madam, if you can change your place, nothing will happen. Don't worry, madam. We are pouring liquid nitrogen. This is the last experiment. We are in one balloon. Please observe what will happen to the balloon. ಒಂದೊಂದು ಕ್ಯಾನ್ ಬೇಡ, ಹಂಗೆ ಸುರು ಬಿಡಿ. ಬೇಡ, ಹಂಗೆ ಸುರು ಬಿಡಿ. Observe what is happening. Banana also kept there. Banana also kept. I will give that banana to eat. Why I should give good banana only? Are you observing what is happening? Wait. You see, it contracts and again inflated. Banana will get you, don't worry. Absolutely no worry at all. Innೊಂದು balloon ಇತ್ತಲ್ಲ ಶಿವು? What burst? Okay. ಸುರಿಬಿಡಿ ಹಂಗೆ ಶಿವು. ಕಂಟೈನರ್ ಸುರಿಬಿಡಿ ಏನಾಗಲ್ಲ. You see how it contacts. Come. What's your name? Shreyas. You want this banana or that banana?
I don't want any.
He does not want any banana at all. But at least you can enjoy the experiment.
Yes.
Liquid nitrogen is pouring. What is happening?
It is again.
It first gets contracted. Okay. And then
Again
once
inflates.
he stops, let us see. Okay. Okay. ಹಾಕ್ರಿ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಹಾಕ್ರಿ. Heaven, but this is temporary heaven, man. That was wonderful heaven. Those who have not done even an iota of sin, that was heaven. This is ordinary. All of us must have committed some sins. Temporary heaven. Okay. Now, quite interesting. I will show you. Banana. Or banana bacon ತಿನ್ನ. Can anybody explain why balloon gets contracted when it is in contact with liquid nitrogen, and again it regains its volume when taken out of liquid nitrogen? ಸಾಕು ಬಿಡಿ, ಅಷ್ಟು ಮನೆಗೆ ತೊಗೊಂಡೋಗೋಣ, ನಾವು ಕುಡಿಯೋಣ. ಸಾಕು ಕ್ಲೋಸ್ ಮಾಡಿ ಅದನ್ನು. Right? Yes. The more you beat, the more quickly it regains its volume and temperature. Right? Can anybody explain? Enough. Can anybody explain? Those who explain, including teachers, those who explain, he or she will be rewarded here. Right now, on the spot, gold spot. Liquid nitrogen is 70 rupees a liter plus GST. We purchased while coming here 6 liters, right? By the time you go back, only container will be there, right? Can anybody explain? Last chance. So reward will be retained with me only. It is simple gas law called Charles law. Ayyo, award lost. Charles law states pressure remaining constant. Pressure of the entire environment remained constant, right? Volume of a fixed mass of gas is directly proportional to absolute temperature. Liquid nitrogen has a temperature of minus 177 degrees, and at what will happen if you had dipped your fingers, you would have broken your fingers like a teacher breaks chalk pieces, right? And if banana has been put, somebody asked what happened to banana, right? You want to eat this? Therefore I gave you good man, you eat that, or you want this?
No.
Huh? One more? We'll do simultaneously both. ಅದೊಂದು ಕೊಡಿ, ರೆಗ್ಯುಲರ್ ಬಾಂಡೆ ಕೊಡಿ, ಒಂದು ಕೊಡಿ. Drop. having returned from heaven. Very bad. So clap for those who have gone to heaven, right? Idena? What was the balloon which got burst, you know? This is the problem. Anyway, I'm not going to explain all this. With this interesting experiment and with the friends who ate banana, who did not eat banana, who had gone to heaven and who refused to do anything, right? I thank every one of you. I must have tested your patience. It's a long activity. There are so many other experiments, but time is a constraint. And while bringing, few things will happen during transit. I thank KSTA for having given me an opportunity to share my knowledge, to share this with such people who are really great. They have got 4 marks. I am very sure that at least one I will get back. But you should know the science. Leuco dies, right? Knowing science behind every experiment is very important. Everything is frozen there. 70% of banana is water. All that is frozen. Rest all is carbohydrate, K plus energy. At minus one, at zero. Imagine what will happen at minus 177. It is so frozen that it broke like some solid material was dropped. So with that note, if you have got any questions, 5 minutes will be given, right? 5 minutes will be given, sir?
Yes, sir.
If you have got any question. Otherwise, my email.
Or
ID
the
there.
questions can be taken at the tea break now.
Okay, tea break is next.
Yes, tea break.
Okay, wonderful. Thank you very
Sir,
much.
on behalf of KSTA and on behalf of all of us present here, wholehearted thank you, sir, for accepting our invitation. Thank you very much, sir. Round of applause to sir. Now there is a tea provision in our canteen. Before going tea or after going tea, you can visit our planetarium show. Before entering dome, you can remove your footwear and watch the planetarium shows. Thank you.
Eat now, that is the award. Eat.